Alright guys, for this first one we have that Jan is investigating the shape of a model helicopter propeller blades. A cross section of one of the blades is shown. So this is a blade of a helicopter. Now I'm not so sure why Jan is doing this, but we're gonna help her out. And so she tells us that the shaded part of the cross section is the area between the x-axis and the curve with the equation blah. Okay? Now, let's really understand what is going on here. So this equation here, okay, this equation here is giving you this line here, all right? And basically x is going to be the distance in millimeters from the edge of the blade, and y is the height. And so why would you have that x is between 0 and 64? Well, because that is actually how long the blade is, from 0 to 64, okay? Blah, blah, blah. Y is the height. Okay, so Y is going to be height. X is going to be distance. Let's highlight that real quick. It's always worth having in mind. X is distance. Y is height. Blah, blah, blah. All right, so that is the current context of the problem. For part A, we need to find the values of A, B, and C that are shown in the table. And so as you can see, A, B, and C are right there. And so how would you find A, B, and C? Well, let's first understand what this graph is even telling me, or this table, better said. And so this right here, notice how it's an x of 0 and a y of 1. So this point here is 0, comma 1. Ah, that means that this point here is 64, comma 1. Interesting. And so the 3 points in between, respectively, would be 16, comma A, 32, comma B, and 48, comma C. All right, so basically, if I plug in an x of 16, I should get A. If I plug in an x of 32, I should get B. If I plug in an x of 48, I should get C. And so what you can do is that you can pull up your graphing calculator and you're going to plug in the equation that's in red, right? So the equation is red. It's going to be 4 square root of x, right, minus the fraction of x divided by 2 plus 1. And so all you have to do from here is plug in the different x's. See? And so for this first point, we're going to put 16 for x. And we're going to find that this is my value for a. And so a, immediately, a is going to equal, a equals 9. Okay? For b, we need to plug in 32. So I'm going to take the same equation and put 32 instead of 16. Oops. 32 instead of 16. 32 instead of 16. So again, all I'm really doing is plugging in my x values in this equation here. See? And so if you plug in 32, you get a b value of 7.627. Significant figures, you would leave it as 7.63. And for this third one, we're just going to plug in 48. And that, ladies and gentlemen, is part A. Notice how part A is worth 3 points. So I think it's some very easy 3 points. So for C, we get 4.71281. If you want to do significant figures, sorry I didn't explain it before, but it's pretty straightforward. You're going to count 1, 2, 3, and ask yourself, do I round this up or down? I mean, do you keep it the same or do you round it up? You keep it the same. And so you're going to leave C equals 44.71. All right, so that is A, B, and C. So that is for part A. For part B, they first tell us that Jan uses the, oh shit, the trapezoidal rule. Here we go again. With 4 intervals to estimate the shaded area of the cross section of the blade, and to find Jan's estimate of the shaded area of the cross section using the trapezoidal rule. Now, the trapezoidal rule, if you open up the formula booklet, you're going to find this. And you're probably going to look at this and say, man, what the fuck am I looking at? Okay? And so, although it's very important to understand what the formula booklet has, understand that it's a tool, and by the way, the day of the test, you walk in with, I don't know, like 2 years of studying your brain, 2 hours of sleep, a pen, a pencil, your graphing calculator, and your formula booklet, and a whole lot of motivation to do well. That means that all of these tools, you have to keep in mind, you have to practice with them. Okay, so always practice with the formula booklet in hand, because the day of the test, you will have a formula booklet. This is an additional tool. Now, it's not enough to know what's in it, you also have to understand what it is. And so a lot of you probably look at this and have no idea what the heck is going on, right? Trust me, I was one of those as well. So let's first understand the intuition, the intuition of the formula book, of the trapezoidal rule. And so trapezoidal rule, what it does is that it helps you find area under a curve. Okay, it helps you find the area under a curve. As you can see here, we're going to use it to estimate the shaded area. Now, why is it trapezoidal? Well, what is a trapezoid? You're going to end up with a bunch of shapes that look a little bit like this. So you're going to end up with, I don't know, one shape like that, another one like this, another one like that, another one like this, right? And so if you take the area of each of these, okay, and you add it up, you're going to end up with a pretty close area to the shaded region. Now, what would you be missing? You would be missing this sliver here, this sliver here, this sliver there, this sliver there, this sliver there, maybe a little bit there, etc. See? Now, strictly speaking, it's usually just up top what you're missing. But point is, if you calculate the area using shapes, you're going to get almost all of it, okay? But it's very useful to find the area under a curve. You just split it into a bunch of shapes, see? Now, how do you identify how many shapes you use and like the area of these shapes or whatever? That is where the trapezoidal formula or the trapezoidal rule is actually very useful, see? So the first stuff we have to identify, which they actually tell us, is how many shapes you're going to do, right? Here it says with 4 intervals. So think about it this way. 4 intervals means 4 shapes, all right? Now notice the points you have. You have 0, 1, you have the point 16, 9, the point 32, 4.7, the point 48, 4.7 as well. And sorry, this one would be 32, 7.6. And the last one would be 64, 1. And so if you go ahead and put that in your graph, you're going to end up with this guy here. You're going to end up with 16, a, which eyeballing it would be, I don't know, around here. So it would be, probably here would be 16, 9, okay? So around here, we're going to call it 16, 9. Around here, we're going to call it 32, 7. So maybe there. 32, 7.63. And then we have 48, 4.71. So maybe here. 48, 4.71. And last but not least, we have 64, 1. And so technically, these are going to be my 4 intervals or my 4 shapes. Again, not drawn to scale, but I really need you guys to understand like what we're actually doing. Okay, so you're going to find the area of the first one, the second one, the third one, the fourth one, and that is the trapezoidal rule. Now, the trapezoidal rule helps you make it a lot more easier, see, to plug in, to find areas of the shapes, etc. If I look at the formula booklet, here's my equation, see? So let me take a moment to write that equation, and we will be working from there. And so if I write my equation, it's going to be the integral, okay, the integral of, from a to b of 1/2 h, I'm going to say what h is in a second, y0 plus yn plus 2 times y1 plus y2 up until the second to last n. And you know that h is going to be b minus a divided by n. So let's understand this better. See? Here you literally have an integral, which will help you find the area of the curve. See? Now it has this symbol and not an equal sign because it's an approximate. Okay, this is approximate, this is equal. It's an approximate because, as I said, there's going to be some parts of your graph that you're not going to acknowledge as area. See? The tippy top. Well, h they define it as b minus a divided by n. See? And so this is going to be h, this other one's n, careful. And, well, what is the difference? So a and b is going to be like which part of your graph you're considering. See, and these are going to be x values. So a is going to be smallest x, and b is going to be biggest x. Ah, that's pretty straightforward. So what's my smallest x? 0. So a equals 0 in this context. And your biggest x, 64. Okay. And now for n is basically like the amount of y's you have. See? Now notice, basically this here is just going to be your last y. Sorry, let me rephrase that. So y0 is going to be your first y plus your last y. Okay? That is why what y0 is saying. It's your first y, and yn is going to be your last y. See? And all this is just y's in between. Okay? So again, this is a very intuitive way to put it, but I think it's more friendly. See? And so if y0 is your first y and yn is your last y, well, how many y's do you have? If I go back here to this table, you're going to notice that this one's going to be y0, this is y1, this is y2, this is y3, this is y4. Ah, okay. So y0 is going to be y0, of course, and yn is your last y, which is y4. And so y4 is going to be my yn, so n has to be 4. Ah, and there are my 4 intervals. There are my 4 shapes. Bada bam, bada boom, n equals 4. So if a is 0, if b is 64, and n is 4, that means that h is 64 minus 0 divided by 4, which means that h is 16. Alright, so this is the first and maybe hardest part, is understanding the amount of n's. See? Remember that your first, I think this is the hard part, the first y is technically y0, okay? Keep that in mind. And your last y is be yn. And then your other parentheses is going to be all the y's in between. So now it's going to make a little bit more sense when I tell you that if I plug it in, it's going to look like this. You're going to have 1/2. I'm going from here, see? So you're going to have 1/2 times h, which is 16, parentheses, your first y, which you said was 1, plus your last y, which is y4, which is also 1. All right, so up until now, I have plugged in this, okay? Now I'm going to do the other part. Plus 2 times all the y's in between. So it's going to be a, b, and c. A is 9, plus b, which is 7.63, plus c, which is 4.71. Close parentheses. Now I plugged in everything else. See? And so that is going to help you find the area under the curve. Plug that into your calculator. Nice and easy. You're going to have the 1/2. You're going to have the 16 times 1 plus 1, first y and last y, plus 2 times all the y's in between. So it's going to be 9 plus 7.63 plus 4.71. And so that is a much more intuitive way to understand the formula, which at the end of the day is what we want to do. We end up with the area of 357.44. And so 357.44, significant figures, you would leave it as 357 millimeters squared because we're talking about area. And now, and now we finished part B. All right, I know that explanation might have been a little bit long, but I'm sure some of you needed to understand what the heck this was even saying. See? So hopefully now you understood a little bit better. My last comment is going to be that, remember, this is first y plus last y, and this is just all other y's, okay? Be very careful with the fact that y0 is going to be your first y. A lot of people are confused with that. They think that y1 is their first y. In this context, y0 is your first y. Oh, and this a and this b are going to be your min and max x values, okay? So yeah, there it is. All right. Yeah, and n is going to be like your last amount, your last y. As long as you understand that, the trapezoidal rule suddenly becomes very friendly, and it's really not that hard. Yeah, so that is part B. Part C, part I, they tell you to write down the integral. Write down the integral that Jan can use to find the exact area of the shaded part of the cross section. And so from here, technically, all you really need to do, okay? Notice how the formula of the trapezoidal rule has this part before it that I'm putting now in pink. And so here is the expression of the integral, okay? Let's remember that the integral is going to be the exact area under the curve, while the trapezoidal rule gives you an approximate. And so if you write down part C, part I, right? Technically, the first step is that you're going to be putting A and B, so from A to B, of y dx. Now, if you plug in piece by piece to get your full credit, well, it goes from 0 to 64. Let's remember that those are my x values, 0 to 64, right? So you're going to put integral of 0 to 64. And here, what it's saying is that you are going to plug in the function y and do the integral in respect to x. That is pretty much what's happening. And so what is my function y? My function y is 4 square root x minus x divided by 2 plus 1. So this is my function y. And you want to do the integral in respect to which variable? In respect to x. So you're going to put dx. Okay? That is part C, part I, literally. It's just writing down the integral. And then, hence, we need to use the graphing display calculator to find the area of the cross section. And careful, give your answer correct to 1 decimal place. And so now I just gotta use my calculator to plug this in, and I'm gonna be done. Now, there is a way to do it by hand, but thankfully here they ask you to do it in your graphing calculator. And so you can always use this trick of just finding the integral right away from your graphing calculator. And notice, it's actually worth 2 marks. Because this first one is worth 2, this other one's worth 2. Total 4, okay? Just by knowing how your calculator works, you're going to get 2 points. Literally. So how does it work? Open up your graphing calculator, and you're going to do some mathy stuff. So you're going to press the math button. You press the math button, and you got to scroll a bit, and eventually you find this thing that says fn int. Think about it this way. It's like the function of the integral. So you're going to press, and boom, there's everything you need. And so here you're going to plug in the 0. So from 0 to 64 in respects to the function 4 square root x minus x divided by 2 plus 1, the integral in respects to x, and you press enter. It loads a little bit because, hey, integrals are not easy, but eventually that's what you get. So my answer was 405.3333, right? Eventually 6. Now notice, they want your answer correct to 1 decimal place. So you're going to go ahead and count 1 decimal place and say, okay, do I round this guy up or down? Do I round it up or keep it the same? You keep it the same. And so you're going to do 405.3 millimeters squared because we are talking about area. Area is going to be squared. Volume is going to be cubed. And distance is just going to be to the power of 1. right? Which is the same as leaving it as m. All right, cool. So that is part C, part II. Then part D is calculate the percentage error of Janss's estimate. Okay, what percentage error? Let's remember that the trapezoidal rule is an approximate. Remember how you said that there's a difference between equals and approximate? Yeah, trapezoidal rule is an approximate because there's a bunch of area that the trapezoidal rule does not consider. Is that a good approximation? Yes. Is it perfect? No. The integral is perfect. The trapezoidal rule is not. And so we need to see by how much it's off, right? By how much it's missing. And that is why it's asking for the percentage error. How much is it missing, etc. Now, some of you are going to read this and say, fuck, I never understood percents. I don't know how to do this. I should have studied more. And some of you, which follow my advice of get familiar with the formal booklet, are going to read this and say, shit, I don't remember percentages. I suck at percentages. But I've heard about percentage error. I know it's in my formal booklet, and you're going to take it out, and you're going to start digging. And you're going to start digging, and eventually, percentage error, there it is. And you're going to look at it and slowly start remembering how it works. And you're going to say, ah, right. And so we're going to have that VA is A for approximate. So here you have your approximate minus your exact divided by exact. Ah, okay, times 100%. All of this with this weird symbol. See? That weird symbol is what is called absolute value. Okay? An absolute value, what it does, for example, the absolute value of 4 equals 4. The absolute value of -3 is 3. The absolute value of -20 is 20. And the absolute value of 20, is 20. And so essentially all the absolute value, what it does is that it makes things positive. If only I could apply absolute value to my life, I might look at things differently. Anyways, absolute value makes things positive, okay? Why is that useful? Because I don't know, if you're talking about a percentage error or percentage change, you're not interested if you like grew 7% or you were off by 7%, like or you were less by 7%. All you want to know is how far off you were. Not if it was plus, not if it was minus, just how far off you were. Okay, that's why percentage error is going to use absolute value in its equation. See? What really matters though is remembering that it's in your formal booklet so that you get these 2 easy points and following the process to get what you want to what you got to get what you want to get. So percentage error, as we said, is absolute value of your approximate minus exact divided by exact. Okay? All of this times 100% just to put it as percent. It'll make sense in a second. So for now, let's just do this part. See? Now again, it's important to understand which one is your prox, which one is your exact. As I mentioned, the integral gets the exact value, and the trapezoidal rule is the approximate. And so here, the approximate, which we got earlier, is this one here, the 357, right? And you can subtract it by the exact one and divide it by the exact one. Now, just to be consistent, technically, following through from my answers from earlier, this has to be just one decimal place. And over here, I left it in significant figures. So I'm going to go ahead and go like this, just to be consistent. And so if you press enter just with this, you're going to get this decimal. See, you're going to get the decimal negative 0.1191. From here, okay, what the absolute value does is that it turns it positive. So you end up with positive 0.1191. And the moment you multiply by 100%, all you're really doing, it's not really that you're multiplying by 100%, you're multiplying by 100, okay? And so what this does, if I first turn it positive, with the absolute value, okay? And then I multiply it by 100. Notice what the decimal does. You're moving the decimal place twice to the right. And so if I move this decimal place twice to the right, you end up with 11.91. Ah, so really, this is a trick to put decimals in percent. Multiply by 100, put the percent symbol, okay? The key idea is multiplying by 100 or moving the decimal place twice to the right, okay? Anyways, your answer is going to be 11.91%. If you use three significant figures, you can leave it as 11.9%, all right? So that is for part D. If you look at the answer key, okay, if you look at the answer key, it says that the answer is 11.8, and that is if you use the long version of 357, okay? I decided to be consistent, use the answer from part B as it says here, and they accept your answer of 11.9. What is my message? As long as you're consistent, you're going to get the answer, you're going to be fine, okay? As long as you learn the method of these exercises and follow the due process, you will be fine. So I hope that anyone that watched this feels a little bit better about percentage error and trapezoidal rule. Remember very well how the formula works. If you're familiar with the formula booklet, you will be just fine. And that is for number 1. Alright guys, just so you know, there's some machinery right outside my house. So if you hear it in this video, it's just that, alright? I don't think the mic should pick it up, but yeah. Number 2, we have our good old friend Ansel, who is designing a racing track for a local bicycle club. The following diagram shows an incomplete portion of the track. And so clearly the incomplete portion is something that goes like this in order to connect the two tracks, right? And so our good old friend Ansel wants to design the track such that the inner edge is a smooth curve from point A to B, which is what I put earlier, and the other edge is a smooth curve from point C to D. The distance between point A and B is 90 meters. Okay, so these 90 meters are this whole thing right here, all right? As this arrow is telling us. So, why didn't I just do that? Well, you want to first get the context of the problem, but also make sure that all the numbers they give you are actually in your diagram, and if they're not, draw them in. And so right now, everything that they told us is in our diagram. Nice. And to create a smooth curve, Ansel first walks to M, which is, ding ding ding, keyword, midpoint of AB. So M for midpoint, M is the midpoint of AB, and to write down the length of BM. Alright guys, this is pretty standard stuff, so if this is the midpoint, that means this is the middle between both A and B. And so that means that this distance that I'm putting in red is the same as this distance that I'm putting in red. And so the length of BM is one of the red lines right here, right? So this is the length of BM. And so, okay, if you have two red lines that are worth the same, right, in distance, right, and the whole thing is 90, that means for finding BM, you just need to do 90 divided by 2 gives you 45. Don't forget your units, 45 meters. So that's some pretty standard stuff. You just need to understand what they mean by midpoint. That is part A. Then they keep telling us a bunch of other stuff. That Ansel then walks 32 meters in a direction perpendicular to AB to get from point M to point E. And so this would be point E right here. So that means that, okay, we just found out that this is 45. And then this right here from M to E is 32. Okay, that is what we know right now. Point E, they also tell us, is the center of a circle whose arc will form the smooth curve between points A and B on the track, as shown in the following diagram. So these lines that I'm now putting in, I don't know, whatever, purple, right? So from here to here and here to here is sort of what I drew earlier, okay? And what the problem is telling you, like, okay, to generate this arc, technically this comes from a full circle, right? Mathematically. And the center of that circle is right here on point E. Okay? And so in order to generate the arc, our girlfriend Ansel, first of all, has a lot of time on their hands, and second of all, is dedicated to making this sort of circle. Okay, and so this sort of circle is the one I'm talking about. That is why Ansel is doing what he's doing. And yeah, that is the current context. And so for part B, notice we immediately have something that is part BI and part B double I. The cool thing about the IB, if anything, is that whenever you have an exercise with two parts to it, they are completely and utterly related to each other. So I know a lot of times they say, como, what you need from part B is what you use from part A, but not always. So it's a hint, but not always. Be careful. Okay, whenever you have like part one, part two, in my experience, they are always related to each other. So that's the first hint that I can give you guys. Whatever you get on part BI is what we need for part B double I. That being said, part BI, we need to find the length of BE. And so the length of BE is this right here. Now, I know this diagram can be a little bit overwhelming. There's like a track and there's like technically there's like a circle going around and there's like these two arcs and like a bunch of different stuff. I know it can get a little bit confusing. But whenever they ask for the length of something, just focus on that something, okay? Of all your diagram, you're suddenly gonna realize once you concentrate enough that you just need to focus on this length, and this length is associated to this triangle. So suddenly part BI is much easier because you are only looking at this. You're only looking at B, at E, and at M. And you're going to plug in all the information you know. On the one hand, this is 45 for distance. On the other hand, this is 32. And the length BE is what you're trying to find. Do you know anything else? Yes, you do. Here they tell us, and I didn't point it out earlier, in case you might have noticed it, is that Ansel then walks these 32 meters, which is the 32 I put right here, in a direction perpendicular to AB. So if it moves in a direction that is perpendicular, that means bada bim, bada boom, ladies and gentlemen, we've got a 90-degree angle right there. And this is a mathematical rule, okay? The word perpendicular, so you usually have what we call, wait, hold up, that is not an E, okay. This is probably not an R either. So perpendicular, so you usually have either parallel or perpendicular, see? So we talk about parallel lines, parallel slopes, perpendicular lines, perpendicular slopes. It's pretty much a synonym. And so parallel lines, it's probably a little more familiar. It's two lines that never touch. But why do they never touch? They never touch because they have the same slope. So if this is line 1 and this is line 2, for parallel lines, slope 1 equals slope 2. In that way, for example, the slope of this first one that I'm putting in green, like this is how much it advances per x. Well, for line 2, it's exactly the same. And so because they grow in the same manner means that they will never touch. For perpendicular lines, it's a little bit different. It's like they cross each other, but it's at such a way that always for line 1 and line 2, you will have that the first slope times the second slope is negative 1. And so technically from here, the first slope is going to equal the second one flipped times a negative, right? It's a mathematical rule. So for perpendicular slopes, you can flip it and multiply by negative 1. Now, why am I saying all of this? Because technically, because they are the negative reciprocal, just trust me on this, you will always have 90-degree angles in all these four sides. As long as they're perpendicular, you gotta be thinking in 90 degrees. All right, so perpendicular, 90 degrees. Perpendicular, 90 degrees. Perpendicular, 90 degrees. All right, so all of that blah blah was just to tell you like this small word this small word perpendicular is telling you that this is 90 degrees. And now, bada bim, bada boom, a bunch of different tools show up. And so, ladies and gentlemen, if you're trying to find the missing side on a right-angled triangle, you should be thinking in the famous Pythagoras theorem. Now, Pythagoras theorem, you can only use it if you have a 90-degree angle on a triangle. So whenever you have Pythagorean theorem, we're going to call this A, we're going to call this B, and we're going to call this C. Okay? Now notice, C is like the long one. C is the one that is alone. And so in the formula, A squared plus B squared equals C squared, all that really matters is that the C that you pick has to be the one that is on the hypotenuse. Okay, the long part. C has to be on the hypotenuse, has to be on the long part. Technically, you can mess up and call A B or B A, and it wouldn't really matter because it's on the same side of the equation. It's just going to be flipped, right? I mean, what's the difference between this and this? But there is a big difference if you confuse your C. So all I'm trying to tell you to really keep in mind for the Pythagoras theorem is that C has to be the hypotenuse, which is very fancy math language for saying the long one. Okay, so the long one is your hypotenuse. How else can you remember it? It's the one that is opposite to the 90 degrees. So for example, this 90 degree, its opposite is side C. This 90 degree, its opposite is X. Ah, so now I can say, okay, whatever, 45 squared plus 32 squared equals X squared, right? X being the length of BE. And so from here, let me just pull out my trusty rusty calculator. Here you can say, well, if you want to skip a bunch of steps and look really, really cool, you can actually do the square roots right away. And so this goes away with this. You end up with X equals the square roots of this. So that will be the length of BE. And if I plug all of that in just to show you, so you guys trust me, because I am, after all, just a guy on the internet. You usually don't want to trust guys on the internet. You can put all of this into your calculator and wablam. X equals this. So X equals 55.2177. Okay? If you want to do significant figures, you would be counting 1, 2, 3, and ask yourself, do you round it up or keep it the same? Clearly, you keep it the same. So significant figures, if you want, you can leave it as 55.2. So the length of BE is going to be 55.2. That is for part BI. And now you're going to find angle BEM. How do I know it's an angle? I know it's an angle because when they ask it like this, with a little hat, it's saying find angle E that is generated by sides B and M. Because angle E, technically, you guys, angle E can be so many things. I mean, angle E can be this guy. Angle E can be this guy. Angle E could even be this guy. Okay, so how do you know which is which? Well, they give you the B and the M, right? So, and because we're in this context of the triangle and everything, it just makes a lot of sense that you will be saying, okay, so I'm looking for the angle that is enclosed by B, enclosed by M, the one's next to it. Okay, I'm looking for this angle, see? Which is this angle here. And so now, well, this triangle now has more information. You know that this is 55.2, right? So you know that this is 55.2. And you need to find angle BEM, which is the guy that I put in, you know, coffee color, in brown, whatever, okay? Yeah, so this is what we're trying to find for part B double I. This is what we're trying to find for BEM, see? From here, there's a couple of tools, okay? And now I wanted to take a moment to talk about the ideal approach, in my opinion, for, whoops, you might have seen secret information there. The correct approach that I suggest for trigonometry, okay? And so clearly from here, because you're in a triangle and you're trying to find angles and sides and a bunch of stuff, we're talking about trigonometry. So the approach that I suggest for trigonometry is the conservative approach. Okay, what's always going to work is first try sine rule and then try cosine rule. Okay, this is the order I want you to employ. Now, if you want to do like a shortcut, okay, so I'm going to put trig shortcut. A trig shortcut is to consider the SOHCAHTOA, okay? And here I'm talking about, better side, I should say sine, cosine, tangent, SOHCAHTOA. Okay, so trig shortcuts would be this, right? But for this, you need a right angled triangle. So that means we're talking about a 90 degrees going around, see? So whenever you have a right angled triangle with 90 degrees, you can use SOHCAHTOA. Now, this is a shortcut. What I suggest, which is the more conservative approach, is using sine rule and cosine rule. What's the intuition of this? Sine rule works in pairs, while cosine rule is basically like one missing side or angle. So whenever you have only one missing side or only one missing angle, or better said, you're looking for just one missing side or one missing angle, cosine rule is pretty good. Okay? Now, I know that one missing angle sounds kind of weird because, oh, you have 2 out of 3, you can get the last one easily. Really, the cosine rule, you know what? I'm just going to show you. Okay, I'm just going to show you. You got to get familiar with the formula booklet. So here, if I go to cosine rule, as you can see, there's 2 versions of it, right? You have the version on the left, you have the version on the right. And so the version on the left, it has a small c that's alone. See? The one on the right has a big C that's alone. There's big letters, there's small letters. What the heck is going on? If you pop out a triangle, okay, the big letter, for example, angle A, big A, is associated to little a. Angle big B is associated to little b. And angle big C is associated to little c. Okay? So in other words, little letter is a side, big letter is an angle. And so for cosine rule, if you're looking for one missing side and you have the other 2 sides, right? And you have the angle of your missing side, you can use cosine rule. So again, if you're looking for one side, you have the other 2 ones, and you have the angle associated to that side, you can use cosine rule. While the other version is, yo, I'm looking for one angle and I have all the sides. Alright, so that is what I tried to express earlier. So it's not really that you're looking for just one side or angle, but maybe now it makes a little bit more sense. See? While the sine rule clearly works in pairs, because you have 2 equal signs, you can just look at it like this. Okay? Now, to leave this a little bit more intuitive, okay, you have little letters on top, big letters on the bottom. So all this is really saying is that your side 1 divided by sine angle 1 equals your side 2 divided by sine angle 2. So as long as you have like 2 pairs, right, and maybe you're missing just one of these, so let's say you're missing only sine angle, well, you can get sine angle alone, okay? So you got to think about it in pairs for sine rule. Cosine rule is a little bit weirder, so that's why I suggest doing it next. And that is the approach I will say, see? So a trig back to reality, basically. A trig shortcut, okay, is that whenever you have a right angle triangle, you can consider sine, cosine, tangent. Now, sine, cosine, tangent, we remember it as so and ka and toa. And if you never learned it, well, you can learn it now. So SOHCAHTOA, for example, you have a triangle like this, okay? I'm actually going to redraw the triangle that we have. And so the triangle that we have, we said that this is M, this is E, this is 32. So it's the same, just flipped, okay? This is 45, and this is 55.2. And we need to find this angle here, okay? So I just redrew it to make it a little bit more friendly. This is the angle we're trying to find. Whenever you have a right angled triangle, you can use SOHCAHTOA. And so the idea is the following. So is for opposites over hypotenuse. And this is a reference to sides. So if you have the sides opposite over hypotenuse, you can use this. If you have the sides for ka, it's going to be adjacent over hypotenuse. Adjacent is right next to. So if you have this, you can use ka. And for toa, you have opposite over adjacent. If you have these, you can use tangent, right? Now, all of this is in respect to an angle. So for example, for this angle here, right, we have to consider like what we can use for this angle, right? And so technically, technically, if you're thinking about the perspective of this angle, one approach that you can employ, okay, one approach that you can employ is that you say, okay, we're gonna call this theta, just to like represent an angle. Okay, so if you go ahead and call that theta, you can say, you can actually use all of these. So you can say that sine theta, okay, sine theta would be opposite over hypotenuse. So the opposite would be 45 because it's on the other end. The hypotenuse is always going to be the long side, so the 55.2. So you can say opposite over hypotenuse, right? And from here to get this theta alone that's in here, you need to get rid of the sine. And so what's the opposite of sine? Sine inverse. So if you do sine inverse to both sides, which is the same as like dividing by 2, okay? It's just something you need to do to both sides. You can do sine inverse to the other side. You end up with only theta, right? So only theta, which is the angle you're looking for, is sine inverse of all of this. Make sure that your calculator is in the mode degrees. So again, I pressed mode, went to degrees, and here, so sine inverse of this, gives me this value here. So angle BEM is 54.60. All right. 54.60, I can just leave it as 54.6. All right. So this is going to be my angle theta, and this is going to be for part B double I. All right. Now, you can just skip ahead and go to part C. Now I'm going to show how you can do it with sine rule. Okay. So to do it with sine rule or any other of the ka or to or whatever, see, for example, for cosine, you would say cosine adjacent hypotenuse. So adjacent hypotenuse, adjacent is right next to. So right next to is 32. And you might be thinking, isn't it 55.2 right next to? And I would say, yes, it is right next to it. But before that, it's the hypotenuse. And so adjacent basically is the one next to it that is not the hypotenuse. So for cosine, you can set it up as cosine theta equals adjacent over hypotenuse would be 32 over 55.2. So from here, you end up with cosine inverse of 32 divided by 55.2 if you follow the same process. And lo and behold, it should end up being the same thing because we're trusting math, we're trusting the process. It's pretty much the same thing, right? So because of decimals, it's just a little bit different. But with three significant figures, 1, 2, 3, you round up this 5, you end up with 54.6, okay? And if you want to do tangent, which is usually the weirdest one, so if you want to do tangent, you are ignoring for tangent, you would be ignoring the hypotenuse. You only care about opposite and adjacent. So I'm going to do that in blue. Okay, so opposite would be this. Adjacent would be this. You would be saying tangent of theta equals opposite over adjacent. Okay, so tan inverse of this would be 45 over 32. And this should also give me 54.6. 45 divided by 32. The same idea. So you count 1, 2, 3, round it up or keep it the same, you round it up, 54.6. So that is showing how to do like a quick shortcut with SOHCAHTOA. Whenever you have a right angle triangle, it works. Now, as you've seen in my videos, I always suggest, I don't know, SOHCAHTOA, I know it's confusing for a lot of people. The whole thing about using tan inverse in order to get rid of the angle, like that can get fishy sometimes, see? And so I usually suggest sine rule. And so for sine rule, you'll be thinking in pairs. And so let me just erase a bunch of this information. And actually, let me do it from here. Okay, let me do it from here. And so from here, you would be thinking in pairs. And so technically, do you have a complete pair? Yes. You have this 90 with this side. And so immediately, you can already say that you have the side 55.2 divided by sine 90. Okay? And all of this is going to equal, well, you want to find this angle associated to that side. So all of this is going to equal 45 divided by sine that you're trying to find. We're going to call it sine theta. Okay, whatever. This is now going to be theta. So this is theta. You're trying to find sine theta. And so from here, well, how do you solve it? You end up doing cross multiplication whenever you have two fractions equaling each other. So you end up with 45 times sine 90 equals 55.2 times sine theta. Okay? And so from here, in order to keep getting theta alone, you can do divide by 55.2, divide by 55.2. So that means that this goes away with this. In order to keep getting sine theta alone, you can do sine inverse once again. So sine inverse of all of this and sine inverse of all of this. So that means that with the sine inverse, this goes away with this, and boom, you end up with only theta. So theta is going to equal all of that, which yes looks nasty, but trust the process, it's going to work out. I'm going to go ahead and do sine inverse and then put a fraction. 45 times sine 90 divided by 55.2, close parentheses, there it is, 54.6. Theta equals 54.6. All right, that is basically just like a million ways to solve it. I'm sure one of them comes to mind. I'm not going to show cosine rule because I am strict to my law that you first try sine rule, and if that doesn't work, go to cosine rule. In this case, I do not need to reach cosine rule. I could have shown it, but I'm not going to show it. Because what I suggest you guys is go to sine rule. If that doesn't work, go to cosine rule. In this exercise, sine rule worked. I'm not going to show cosine. If you want to look at a cosine example, you can look up a lot of my videos. Just put the buzzword cosine rule. That being said, on the one hand, sorry for making such a long video, but on the other hand, I'm sure someone out there really appreciated what I just did, so this one's for you. I hope it helped. Now, for part C, you need to find the length of arc AB. And so here there's a lot of stuff that can sort of like jump out at us, okay? On the first hand, they use the word hence, which sounds very fancy. It is raining, hence I took an umbrella. I was hungry, hence I cooked some fried eggs with salt and pepper. Alright. Anyways, so hence, besides being a little bit fancy, is also like, it's like therefore, okay? And so, this is a big hint because, everything I did in part B, because they put this hence, means that it's super useful for part C. And so this is a big, big hint that, okay, part B was extremely relevant for part C. Whatever I did in part B, I needed to find the length of arc AB. And so this is another big buzzword. What is an arc? So once you play around with your formula booklet enough and you study with it right next to you, down here you have length of arc, area of sector. Now an arc comes a little bit from arcway, okay? And so an arcway is like you have two pillars, and the arcway is this part here, okay? This would be your arcway, all right? And so in this exercise, the arc, as you can see, is this guy here. Now, technically there's two arcs, right? There's the arc that's like on the bottom, see? And there's the arc that's on top. In this case, they want you to find arc AB, the one at the bottom, the one that I just put in black, okay? So how can you find the length of arc AB? This is why the formula booklet exists. You read the word arc, you jump over here, and you say, yeah, I know there's a formula for length of the arc. Maybe I forgot how it was. You're not supposed to know it by memory, but you are supposed to identify arc equals formula booklet equals find it. And so you find it, and you stare at it, and it says length equals theta divided by 360 times 2 pi r. What the heck is theta? What the heck is r? What the heck is pi? So theta, they tell us, is the angle measured in degrees. Okay, so it's just like a normal sort of way to call an angle. You also have radians, but for the IBAISL, I'm pretty sure we don't care about radians, all right? And they also tell you that r is the radius. And so radius for a circle would be from here to here, this is radius, okay? A radius plus a radius gives you the diameter, okay? And if you put all of this in a diagram, it looks like a Pokeball. Anyways, so you have the circle, this is radius, radius plus radius gives you diameter. So diameter is 2r, okay? Or technically it would be r plus r, you end up with 2r, okay? Enough blah blah. And so the length of the arc that you're trying to find is AB, right? And so the angle right, the angle that you need to find the length of the arc, right, would technically be this whole angle. This whole angle is what you need, right? And so if you find that whole angle, you can find this whole arc, okay? In other words, what you have right now is that you have this and this, right? I need to find the length of this arc here, okay? And what is information you have? Well, you just found that the radius from part B was 55.2. So this is E, this is B. So this is 55.2, which means that this is also 55.2, right? And you just found that this angle here, just this angle here, is 54.6. And so the length of the arc that you're trying to find that's in red means that you need this whole angle. And so from here, it's pretty standard because Ansel walked in a direction perpendicular to AB. That means that these triangles are like pretty much perfectly the same, okay? And so this angle in red is actually going to be 54.6 plus 54.6 because technically this green angle here is the same one. And so the big angle in red, which is what we want, is going to be 54.6 plus 54.6. So the angle in red is 109.2. Okay, now we're getting somewhere. So now I can erase this stuff in green. This whole thing in red is 109.2, right? And so if this whole thing in red is 109.2, now I can pretty much plug in length of an arc. So length of an arc we said was theta divided by 360 times 2 pi r. So from here you can plug in theta, which is going to be 109.2 divided by 360 times 2 times pi times r, which we said was this guy here, 55.2, right? Now you might be thinking, why is he not plugging in pi? And I'm saying, I'm not plugging in pi because technically pi, your calculator has it. Okay, you can plug in pi by pressing this blue button here on top of this, okay? And so you can press second, this button here, you hit pi, okay? And pi is just a really long number, see? I'm not gonna get into why pi exists, but it has to do with circles, okay? Anyways, from here you can say, you can plug all of this in, okay? So you can plug all of this in saying alpha y equals, pop out a fraction, just to make it easier to plug in stuff. So 109 divided by 360 times 2 times pi times 55.2. Bada bim, bada boom, the length of the arc is going to be 105.205 is what we got, right? And if you count three significant figures, you count 1, 2, 3. Do you round it up or keep it the same? You keep it the same. And so for part C, therefore, we have an arc length of 105 meters. Okay, so that is for part C. Later on, they tell us that the outer edge of the track from C to D is also a circular arc with center E, such that the track is 4 meters wide. Now careful, what we just found, right, was the arc that I put in red. And technically in this exercise, you also have like the outer arc, right? And then here you have your track, here's the outer arc, here you have your track. Okay, sure. And so what they're telling you is that, okay, this is 4 meters wide. So from here to here is 4. From here to here is 4. From here to here is 4. Okay, and it also has center E. And we calculate the area of this curved portion of the track. A, B, C, D, E. A, B, C, D, E, F, G. A, B, D, C. So let's go back to the original diagram because it's what has the most information. So technically, they want to find the arc that is A, they told us A, B, D, C. So it's going to be all of this, okay? Okay, clearly that was some terrible drawing, but you want to get the area of this, 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 and this. So they're looking for this shape here, everything that's in white. And what do they tell you is that the distances from here to here are all 4, okay? And so this is a big hint for what's coming. let's establish how we can solve it, okay? And so, for finding the area of this particular shape, it's pretty hard. It's definitely not in your formula booklet. Like, yo, if there's ever a scenario where my friend Ansel wants to find the arc and the sector, and dude, you're not gonna find that, okay? But what you are gonna find is that for circles, okay, you have two main tools in terms of area and length and blah blah blah. So you have length of arc and area of sector. So let me talk a little bit about the difference between the two. So let's say you have this example here. Let's say you have, I don't know, this is R, and this is your angle theta. See? If you were, oh, and this is going to be like a triangle that goes like that, okay? So if you were to use length of an arc, which I will put now in green, length of an arc gives you this. Well, area of a sector, which I'm going to put in pink, so area of a sector, notice it's area, so area of a sector would literally be all of this. So these are your main tools. So area of sector gives you like the whole thing, right? And so technically in this exercise, what we can do is that we can find the area of a sector. We can first find this area of a sector, which I will put in pink. So we can find this area of a sector. Then we can find this area of a sector that I'm putting in green. So all of this, okay, which also covers the pink, right? And from here, if you do the green, which is the bigger one, minus the one that I put in pink, you're going to end up with exactly, this is A, this is D, this is B, this is C. You're going to end up with the small sort of sliver at the end of A, D, B, C. Okay, so you're taking the area of a sector twice, first the big one, then the small one, subtracting both, and clearly you need to end up with only what is in here. Okay, you end up with only this, which is exactly what they're asking for. So that is the game plan. So for the big sector in green, right? So for the big sector in green, they tell you that all along it you have a length of 4. So here, you have a length of 4, including at the very edge. So technically, this distance here, which is the radius of the bigger one, is going to be 55.2 plus 4. So the radius of this big circle, right? So the radius of this big circle is going to be 55.2 plus 4. It's going to be 59. Oops, that is 49. Lol. It's going to be 59.2. Well, the radius of this smaller one is our classic 55.2. Now, because they are the same arc, just that one of them is bigger than the other, right? The angle that we're going to be using is the same. 109.2 and 109.2. Alright guys, I know this is a little bit confusing, but this is probably as clear as I can get, okay? So, point is, from here, the area of the green one, right? Remembering our equation up here, or actually, for area of sector, you have this. So for area of sector, let me put it here, area sector is theta divided by 360 times pi r squared. Pi r squared. And so for the area of the green one, so area green is going to be the 109.2 divided by 360 times pi times r squared. So 59.2 squared. Minus, and now I'm going to be putting the guy in pink. The guy in pink is going to be 109.2 divided by 360 times pi times r, which is 55.2 squared. And this will equal the area of the thing I'm trying to find. So just to be mega clear, this in green is the sector of the big one, right? And this in pink is the sector of the smaller one. And so if you take the big sector subtracted by the small sector, you end up with the small sliver that you need, right? Of ADBC, okay? So once you do all of that, you end up with, well, look at me spend some time in my calculator. You can just be very careful with how you do this, right? So I suggest using a lot of parentheses here. So this first big parentheses is going to be the stuff in green. So I'm going to have 109.2 divided by 360 times pi times 59.2 squared. So I close this first big parentheses, and this big parentheses is being subtracted by my next big parentheses, which is the guy in pink. So for the guy in pink, I said it was 109.2 divided by 360 times pi times the slightly smaller radius, 55.2 squared. I close all of it. I double check that the parentheses look okay, that the squared also looks okay. Looks all good to me. I press enter, and this is what I get. And so the area of this thing is 436.069. If you want to do three significant figures, you count 1, 2, 3, round it up or keep it the same, you keep it the same. So the area for part D is simply going to be 436 meters. Because it's area, it's going to be squared. Okay, so if it's area, so area is going to be meters squared, volume is going to be meters cubed, and distance is going to be meters to the power of 1, which is the same as just leaving it as meters, okay? So area is going to be squared, volume is going to be to the power of 3, distance is to the power of 1. Careful with that, it's part of how you put your answer. Then they tell us that the base of the track will be made of concrete that is 15 centimeters deep. And so, for part E, we need to calculate the volume of the concrete needed to create the curved portion of the track. So if I get very, very fancy with my math drawing skills, you have A, you have D, you have B, and you have C, right? And so technically right now they're telling us, okay, we need to put some concrete on like below this whole part. So if they put some concrete below on all of this, you need to find the volume that fills up like the inside. You know what I mean? And so you need to find the volume of everything that is right below this track. Right? So from here you have B, there you have C, right? So you find the volume that fills up this track, right? And so this has more to do with understanding how calculating volume in general works, okay? So for example, if you have a cube that looks something like this, for finding the volume of this, all you're really doing, or how volume is created in the first place, technically this cube is a bunch of these squares that I drew at the beginning, like infinite amount of times, okay? And so technically, if you add, this is the thing, if you add the area of all of these different squares, you end up with the volume of the cube. And so in this case, technically, if you add a bunch of different tracks that go all the way down, so you add a bunch of different tracks that go all the way down, like layering themselves, eventually, if you add all of those up, you end up with the volume, okay? That is how volume is created. You're taking like one shape and multiplying it like a bunch of times and adding all of that together, and that is what gives you volume, okay? So it's this one shape like infinite amount of times, okay? And all of that added together is what gives you volume. And so in this case, you want to take this shape and, sorry about that, you want to take this shape and how many times do you want to like sort of multiply it or whatever? Well, you need it to be 15 centimeters deep. So technically you can take your answer from part D, the 436, and just multiply it, right? So this is meters squared, and multiply it by 15 centimeters. And that's going to give you the volume, because basically you're saying this shape here, this shape here, I need it to be 15 centimeters deep, sorry. And so how many times is it going below? Like 15 times. in terms of centimeters. But here, it's not so easy, right? This is worth 3 points. So there's gotta be something fishy going on. And the fishy thing going on is that for part D, you said that the area of the shape that's in orange, right? The ADBC, this guy on top, right? So the shape of this guy, the area of this guy is 436 meters squared. And you want to find the volume when you multiply by 15 centimeters. Uh-huh. So that's a problem. You either go with meters or you go with centimeters. And so I'm just going to show both. See, so on the one hand, you can go the version of meters, right? So the version of meters is making sure everything is in meters. And so in 1 meter, you have 100 centimeters, okay? So that means, notice, from here to here, I had to divide by 100. So, interesting. So 100 divided by 100 gives you 1. So 100 centimeters is for 1 meter. So you can also make this sort of relationship. Okay, so if you're trying to find 15 centimeters, how many meters would that be? Now the relationship is still divided by 100. So you need to do 15 divided by 100, 0.15. And so to leave it all in meters, it would be 436 times 0.15. That will give you the volume in meters. And so the volume in meters would be 436 times 0.15, 65.4. So 65.4 meters cubed would be one way to answer this question. And so there is a world where you leave your answer in centimeters. It's just a little bit more confusing to my sort of intuition, because then with meters you end up with smaller numbers. It's easier to manage. So I suggest that you convert it to meters and you go from there, okay? There is an answer to do it in centimeters. I'm just going to show you meters because I think it's friendlier. And that would be actually for number 2. All right, you guys. So for this third one, we have that the running time, okay, running time in T minutes of 200 family movies are recorded in the following table. Now let's take a moment and look at this table. So here we have a frequency, and also take a good look. We have these symbols here, right? And so these symbols here means that all of these are different intervals. For example, on this first one, you know that you have 11 family movies. 11 family movies between a T between 70 and 80. So there's 11 family movies that have a running time between 70 and 80. There's 47 family movies that have a running time between 90 and 95. Okay? And so that's basically what this table is telling you, right? Now I'm going to say something right away. Example up here, they tell you that this first interval, you have 11 of them, see? You have no idea how that's spread out, right? Because maybe of those 11, you have, I don't know, like 570s, right? So maybe 570s and maybe 673s, right? It can be something like that. Or you can have, you can have, I don't know, 270s, 271s, and whatever, 179, and maybe 675s, okay? Like times 1, times 6, times 2, times 2, okay? And so you have no idea how it is spread out within that interval, see? And so this is going to be relevant down the road for estimating means and stuff like that, okay? But we just need to understand that when we have intervals, we have to treat it like so, okay? And so for part A, part I, we need to write down the mid-interval value, interesting, of 70 to 80. So this first guy here, right? Now, the mid-interval value, following its name, mid for middle, and interval for middle of the interval. So what is the middle of the interval between 70 and 80? The middle between 70 and 80 is 75. Literally. For part A, part I, you are going to put 75 minutes. If you're stressed about showing your work, you can write 70 plus 80 divided by 2. That gives you the 75. Okay? So, yeah, that's part A, part I. Part A, part double I. And remember, anytime you have like I or double I, it means they're associated with each other, right? So for double I, we need to calculate an estimate, interesting, an estimate of the mean running time of the 200 movies. And so when we see the word mean, okay, let's just recall that mean is the same as average, okay? And what we're used to doing for average is saying like, I don't know, 70 plus 71 plus 71 divided by 3, right? And so you have your, notice, exact values, and you divide by your total. So if my data is 70, 71, 71, and I say find the mean of this, you take your exact values, you add them, and you divide by the total. When you have intervals, you don't have exact values. And so how do you do it? Well, part A, part I asks you to find a mid-interval. Ah, okay. So the mid-interval is something we need to use in this context to find the mean. Okay, so yes, I don't have exact values, but then what can I do? Well, your values are going to be the mid-intervals, okay? And so now I'm going to go ahead and add an extra column, just to be very clear, that says mid-interval. All right, and so from here, I'm going to make it very nice and pretty, although my artistic skills, you know, they're all right. Here it is. So here's my extra column that I just added. And so the mid-interval for this first one is going to be 75. The mid-interval for the second one is going to be 82.5, right? Because the middle of these two is 82.5. Remember, you can do 80 plus 85, so it's this plus this, divided by 2, gives you that 82.5. And so you can keep going and fill it all in, right? This is 87.5, this is 92.5, and this last one, careful, this last one is 100. And so here's a small detail you need to notice. You might have thought it would be 97.5, but think about it this way. The spread from 70 to 80 is 10. It's plus 10. From this to this is plus 5. Here's plus 5, here's plus 5, and this again goes to plus 10, okay? So if you're scared about falling into that little trap, right, you can always just add them both, divide by 2. Oops, make sure you divide by 2 at the very end, or else you end up with something a little different, because you would be doing 85 divided by 2. See? Happens to anyone. Anyways, this is a way that you can just always like double check, get the correct mid-interval, whatever. The first time I tried this exercise, I got it wrong because I put a 97.5 here. See? It happens to anyone. I'm just pointing it out. Careful what the difference is from one to the next. Okay? Yeah. Anyways, so now I have the mid-intervals all written down, right? And so from here, for calculating the mean, it works like this. I'm going to put all my mid-intervals in pink in my formula so that it's easier to follow. And I'm going to put all my frequencies in green. All right, so frequencies will be in green. And so technically for your mean, you don't have the exact values, but you have frequency and you have mid-interval. So how do you do it? You say for this first one, okay, for this first one, you would say 75 times 11 plus, for the second one, 82.5 times 51. So basically you're doing the mid-interval. So for the third one, it would be the mid-interval times its corresponding frequency. For this fourth one, it's the mid-interval times its corresponding frequency. And for this last one, it's the mid-interval times its corresponding frequency. And all of this has to be divided by your total because we're talking about mean, right? And so divided by your total, well, what's my total? 200 family movies. What's another way to check your total? Add all the frequencies. And so you can add all the frequencies, and that has to be your total. And surprise, it's going to be 200. All right, so it's 200 by context, but you can also get 200 by adding the frequencies. Okay? All right, cool. And so here we divide by 200, and that will be my estimated mean. Why is it estimated? Because you don't have exact values. But that's fine. You can still get a mean. It's just estimated. See? So let's do a little bit of color coding so that we're on the same page. So these are my frequencies, correct? And these are my mid-intervals, all right? And the 200 is my total, which is sum of frequencies or just by context, all right? Anyways, I put all of this into my calculator. So I'm going to do alpha y equals, press the first one, so I can put a fraction. And here, well, I'm plugging in for like half a year, but it works, see? Technically, you can put it into one var stats, use like a frequency list and stuff like that. But I'll just show it like this, all right? I think it's a little bit more intuitively easy to follow if I show it like this. But yes, you can go into one var stats. Anyways, divide by 200, bada bim, bada boom. There you go. And so for part A double I, we have that the mean estimated, right, is going to be 88.15 minutes, right? If you're the kind of person that loves significant figures, you can count 1, 2, 3, round it up or keep it the same. You round it up, okay? Both of them work. I suggest leaving the long answer. Then we have that this table is used to create the following cumulative frequency graph. And so cumulative frequency, as it says or as you read it, for example, a cumulative frequency over here at 75, right, means that here is your 75th movie. So notice how the total is 200. So movie number 200 has that amount of running time, right? And so notice how this curve looks. They organized all the movies from the lowest running time to the highest running time. So for example, the first or like the 10th or whatever, a movie has a running time of, I don't know, like 77, okay? And so that is how you read this graph. And so now that you understand how to read the graph, everything is a lot more friendly. The cumulative frequency curve, damn, they ask us to use the cumulative frequency curve to estimate the interquartile range. And so interquartile range, you're probably thinking, I think I know what that is, right? And so you're going to go ahead and open up your formula booklet, which is right there. And so over here, you've heard about interquartile range. It's a buzzword you've identified before. And so you look it up and say interquartile range, and there it is. Q3 minus Q1. Now, we need to understand what the heck is Q3 and what the heck is Q1. So, Q3 makes reference to quart, all right? So you can think about it as quartile 3 minus quartile 1. All right. Now, this has to do also with percentiles. All right, so I'm going to talk a little bit about this. And so when you have percentiles, for example, they say you're, I don't know, 70th percentile, right? So that means in your data, it's your data that is right at 70% of it, okay? And the issue is that we're very used to thinking from 0 to 100, right? So your 70th percentile is person 70. But here you have 200. So here it's the 70th, but of 200 movies. So, okay, what's 70% of 200? How do you find it? You do 200 times 0.7. And so your 70th percentile is movie number 140. So if I actually go to movie 140, which would be, I don't know, around here, right? This would be my movie that is in my 70th percentile, okay? So that is how you find percentiles. Be very aware that that your total, okay, is going to help you find where your percentiles, where your quartiles are, okay? And so if we're talking about in terms of quartiles, so I just talked about percentiles. If I talk about in terms of quartiles, think about it this way. Your quartile 3 is your 75th percentile, and your quartile 1 is your 25th percentile. So because it's in quarts, right, it's like 1/4, 1/4, 1/4, right? And so your first quartile is your first fourth of your data. 1/4, how much is that? 0.25. Boom, 25th percentile. While your quartile 3 is these three guys. So it's 1/4 plus 1/4 plus 1/4, 0.75. Boom, 75th percentile, sorry. And what is even another way for you to understand it, when you look at a box and whiskers diagram, okay, whoops, when you look at a box and whiskers diagram, right, it's always going to be, this is your min, this is Q1, this is your median, which is the same as Q2, okay, it's the guy at 50%, right? This is Q3, and this is your max. What is the cool thing about interquartile range is that from min to Q1, you have 25%. From Q1 to the median, you have 25%. From the median to the Q3, you have 25%. And from the Q3 to the max, you have another 25%. And all of this has to do because quartile 3 is your 75th, and your maximum is your 100th. So it's like the top 25%. Interesting. And so interquartile range, yes, it's your range, so it has to be like the biggest minus the smallest, but because it's interquartile, that means you're looking for the middle 50%. So interquartile range, what's cool about it is that it's the middle 50%. This is why people are interested in it in the first place. It helps you find the middle 50% and whatever. It can give you a better notion of how to interpret what you found out. All right, that was a lot of blah blah, but I think I cleared up a couple ideas that some of you may have had. And so if I go all the way back here, and when you estimate the interquartile range, okay, I'm considering Q3, I'm considering Q1. And so to find Q3, I take my total, 200, because 200 movies, right? And I want to find which value is at 75%. And so 200 times 0.75, boom, 150. And for Q1, I'm going to do this 200 times 0.25. And so which movie is at my 25th percentile, or which movie is at my quarter 1? 200 times 25, 50. So, all right, so Q3 has to be at 150, Q1 has to be at 50. So Q1 has to be at 50. So this guy here is going to be Q1, right? So notice Q1 is at 50. Think about it this way. Q1 is at 50. And so at 50, I have, it's probably just 84, right? Yeah, I would call this 84. So Q1 is 84, okay? So notice here, maybe I shouldn't have put equals at 150 or equals 50. It's your Q1 is at 150. I mean, your Q3 is at 150 and your Q1 is at 50, okay? And so at 50, I have 84. So my Q1 is going to be 84. And my Q3 is at 150. So at 150, I have, so if this is 91, that would be 91.5. So that's 91. Right next to it's going to be 91.5. So Q3 is going to be 91.5. So that means that your interquartile range is going to be 91.5 minus 84. Your IQR is 7.5 minutes. All right? So again, not that hard, but you do need to understand how to get Q1, how to get Q3. The cool thing about this graph is that it's kind of easy to read, right? And so this helps you find like your Q1, your Q2, your Q3, like the location, and then you just have to find its corresponding running time or whatever. See? Sometimes you gotta do it backwards, like what they give you here, and then finding where that is. Like, is this the 90th percent, the 100th percent? Like, how much would it be, right? But usually, my experience is the other way around. They basically tell you like who's at the 60th percentile, right? Actually, let's do that example. So, who or slash amount that is at 60th percentile, right? So this is another classic. I don't think it shows up on this paper, but you know, I think I should show you anyways. So they might ask you who or what amount is at the 60th percentile. So you're going to take your 200, you're going to times it by 0.60 for 60 percentile, right? 60th percentile, sorry. And so 120. So whoever is at 120, which would be, I don't know, around here, right? Whoever is at 120, that is the amount for your answer, okay? Which would be a little less than 90, all right? 89, I think. So that's how you read this graph. I hope that at the end of this video, you just feel good about reading the graph, okay? That's the most important part, really, all right? All right, and now for part C, they tell us that Star Feud, I'm not sure if I'm saying that right, is a movie in the dataset and its running time is 100 minutes. Use your answer to part B to estimate whether Star Feud's running time is an outlier for this data. See? And so we have a movie that its running time is 100. So it's right here. See? So that means it's within my data, right? It's within my data and it's in a pretty high percentile, and I'm still not sure which, right? But it's a pretty high percentile. Point is, yes, it's within my data, but it might be a number that's like a little too big and it might be considered an outlier. See? And so what is the mathematical proof for whether it's an outlier or not? I'm going to show you now. See? Now, part of this, all right, part of this has to do with part B. See? So part B, we needed to use the interquartile range, and part C needs something from part B. It's not always the case, but a lot of times it is. Actually, here it says use your answers from part B. See? And so, first of all, what is an outlier? See? An outlier is a value that is too big or too small, and it doesn't make sense that it would be here. For example, a movie that lasts, I don't know, 30 minutes would be like here. See? And as you can see, almost all of these movies start at 70. So it would be a little bit troll, a little bit weird to have a movie that lasts 30. Or maybe they have Lord of the Rings in here and the movie lasts, I don't know, like 180 minutes. and that would be way out on this graph. That is probably an outlier, see? So we have the intuition that outliers are like way too big or way too small, okay? Now, what is the level that you accept, okay? It has to do with the boundary that you define. So think about it this way. Maybe you say anything beyond this is too big, or anything smaller than this is too small, okay? Now, how do you find those values? Well, these would be considered your upper bounds. So anything above that, you would like, you know, um, consider an outlier, or your lower bound. So anything lower than your lower bound is something you would consider an outlier. How do you calculate the outlier? It is awfully specific. It is not in your formula booklet, but it's easy and good points. So this is the kind of thing that you will have to memorize, but if it shows up in your test, I think it's easy points. See? And so here, notice how the running time is 100. There's more on the right side, so I only have to calculate the upper bound. I'm still going to show you how to do lower bound, but for now, let's only do upper bound. See? And so the equation for upper bound has to do with the interquartile range. So for upper bound, you will be doing, because it's on the upper bound, because you're more on this right side, you consider Q3. So on the one hand, you have to do Q3 plus because you're more on the right side, right? Plus because you're more on the right side. So Q3 plus 1.5 times IQR. This is your formula for upper bound. And as you would expect, for lower bound, instead of Q3, you use the quartile that is more on the left, so it would be Q1. And because you're going to the left, right, you would actually do negative. So it would be Q1 minus 1.5 IQR. So there you have figured out how to calculate the bounds. And this is something you should think about if you ever read Outlier. If you ever read Outlier, think about the bounds. Okay? That is a rule of thumb you can do. And this is what I mean when I talk about procedure. See? Read the buzzwords, and through that, figure out what to do. See? Anyways, so the formula for upper bound in this case, we're going to have, so upper bound for real this time, you have your Q3, which is this. So you have 91.5. And because it's upper, we will be adding, so plus the 1.5 times IQR. So IQR we said was 7.5. And so your upper bound ends up being, let's double check. So your upper bound ends up being 91.5 plus 1.5 times 7.5. That looks fine to me. So your upper bound is 102.75. So your upper bound, which I'm going to now put in black. Okay, so your upper bound is pretty much, so if this is 101, that means this is 102. It was 102.75. So it's like around here. See? So anything to the right of this would be considered an outlier, right? So for example, these movies here mathematically are considered outliers, all right? So this is your upper bound. So anything to the right is outliers. These guys are outliers, okay? But the movie at hand, Star Feud, is 100 minutes. And so 100 minutes, we put it in red earlier. It's this guy here, right? 100 minutes is to the left of the upper bound. So you would say, blah, blah, blah. Estimate whether it's an outlier. So you would say, no, not outlier. So on the one hand, that gives you an answer point, right? But for your method, you're gonna, well, this is a method point right here. And your strong justification, all right, like your reason or whatever, is that 102.75 is bigger than 100. So 102.75 is bigger than 100. So this is your reasoning point here. This is your method point for using the formula. And this is your answer for, stating the obvious, no, not an outlier. See? All right, guys. Those are your 3 points. Fairly easy. One of the formulas you just gotta memorize, not in your formula booklet. All right, let's keep going. So here we have that it is believed that the running times of family movies follow a normal distribution with mean 88 minutes and a standard deviation of 6.75 minutes. Now, before we keep going, standard deviation, I need you to associate it to spread. Okay, so a bigger standard deviation means that your data is much more spread out. Okay, and 88 minutes, and your mean, we can associate it to average. Okay, I just want to start off by saying that to make this a little bit more friendly. So on average, these movies last 88 minutes, and the spread from one to the other is usually 6.75 minutes. Okay, usually, right? And so like the movie next to it would be, I don't know, 82, right? And then the movie next to that would be 95, 94, so 88 plus this, okay? Whatever, man, just have the idea that standard deviation is spread, okay? Let's stick to that for now. And then it gets funky because it is decided, for some reason, to perform a goodness of fit test. Now this symbol here is chi. So this is what they call chi-squared, okay? So this chi-squared goodness of fit test on the data to determine whether this sample of 200 movies could have plausibly been drawn from an underlying distribution. All right, and so we need to write down the null and alternative hypotheses for the test. And so for now, all we need to do is the null and the alternative. And so from here, we have the intuition. So null, which is HO, is basically no effect, no change, right? While the alternative, which is H1, is that there is an effect, yes, change, all right? So always think about the null as like no, okay, no effect, and the H1 as yes, yes, there is. And so here, what are they trying to determine? Careful, they're trying to determine whether the sample of 200 movies could have possibly been drawn from an underlying distribution. And so, whether it could have possibly been drawn, right? And so from here, what I suggest, okay, to do is that you can say that HO, right? So no effect, no change, means that they were drawn from this, right? It's like they think it was drawn from this, it got drawn from this, that would be no effect, no change, okay? So the context of the problem matters a lot. So in this context, no effect or no change means that, yeah, they got drawn from a normal distribution, right? Why is it like that? Because that's what they consider. That is their assumption. So you can think about it that way as well. HO like keeps your assumption. HO keeps your assumption, right? And so your assumption is an assumption of no change from the current scenario. And the current scenario that they're saying is that it comes from a normal distribution. Okay? So I know that's a little bit weird, but stick to it. So null, or your HO, is no effect, no change, and that you keep your assumption. And so the assumption that they're doing is that this was drawn from a normal with this distribution, right? And so HO technically from here would be the running times of the movies can be modeled by normal 88 6.75 squared. Okay, this is the first big thing we have to say. All right, so HO is no effect, no change. Keeps your assumption. They're assuming a normal distribution, so it can be modeled, right? And for H1, all right, and I know that HO is usually like not whatever they're trying to say, but in this context, they sort of like throw it to you as a curveball. See, so because they say could have possibly been drawn, that is the assumption they're keeping. That is their status quo. Okay. Usually, the sort of tests that they do is that they're trying to see if like, oh, does this have an effect or not? See, this one is the distribution where it comes from. So the context matters a lot. I know I've given the hint that HO is whatever. It's like not what they say, right? Well, in this case, because it has to do with the distribution and where it comes from and all that stuff, we keep that assumption. See? I know that's weird, but I had to explain it a little bit because, well, it's how this exercise is. So context matters for that kind of stuff. Usually you can just say not HO. See? Usually you say not, I mean, not HO, but you say not what they propose, and it works for HO. In this case, logically it's different. All right, that was a long explanation. Maybe I could have made it shorter, but it is what it is. All right, for H1, think about it as opposite of H0, okay? And so if H0 is that the running times of the movies can be modeled by the normal, if HO is the opposite, is that the running times of the movies can't be modeled by the normal. Yes, that small difference is all you need to do. H1 is opposite of HO. See? All right, so that is for part D. Then for part EI, we're going to find the value of A and the value of B. And so from here, well, we take a look at our graph, right? And we see what they propose. So for example, the running time, if you have t less than 80, the observed frequency is 11. So they had 11 movies that were less than 80. And its expected is 23.6, right? And so there's a way, using the information of each of these rows, to have it make sense in terms of expected frequency, right? And so this does have to do, once again, with the mid intervals, because you're filled with intervals, you work with expected values, with estimated values, with stuff like that, right? And so from here, you can think about it this way, right? Or actually more than the mid interval values, because this is a normal distribution, you gotta think about what are your tools for the normal distribution. You have what is called normal PDF, you have normal CDF, and you have inventory normal, which is like inverse normal. See? In this case, our main tool will be normal CDF. CDF, I need you to think about it as cumulative. So if you have a range of data, you can use normal CDF. Ah, here you have a range. So let's better try to understand how they got to 42.1. So once we understand how they got 42.1 on this example, finding A and B is going to be very easy. See? So how did they get that 42.1? Well, we can go to the calculator, and because it's a normal distribution, I can go to stat. I can go to distribution, so second bars, distribution, and boom, there are my tools. So we said it's cumulative because we have an interval, basically. So normal CDF is for intervals as well. See? Because it's cumulative, it's also for intervals, right? And so from here, you can say, okay, so my lower can be 8. Actually, I did it earlier, lol. So your lower can be 80. Your upper is 85. So this is example in red. See? This symbol here, the U, is mean. And they give it to you right there. Okay? If I look for normal distribution here, do I have the normal distribution here? Maybe I don't. Oh, well, that's mean. Well, anyways, when they give you values, for example, 88 and 6.75 squared, yeah, the normal distribution is mean, comma, variance, okay, or standard deviation squared. And so from here, you can deduce, right, that the mean has to be 88 because it's the first number that shows up, and that the standard deviation has to be 6.75 because it's the 6.75 here, just that you get rid of the squared, right? So basically, you know that this is this, right? And so to get this, you can do square root. This goes away with this goes away with this. Standard deviation is 6.75. So that's how we figured out standard deviation is 6.75. It's all given to you right there. See? All right, cool. And so here I can press paste once I fill in all of my information, and boom, I get 0.21. Now you guys might be thinking 0.21 sounds nothing like 42.1. But what did I just do? What I just did is that I went to my calculator and I said, yo, I have a normal distribution that has a mean of 88 and a standard deviation of 6.75. So from here to here, right? For example, from here it would be a mean plus a standard deviation, and from here it would be a mean minus a standard deviation, right? So your normal distribution looks like stuff like this. And so technically what I just did, if in the middle I have 88, and I'm looking for the guy in red, which is from 80 to 85, that means, okay, maybe around, I'm making it up, okay, but maybe around from here 80 to 85. That's what you're asking for, okay? And so if you put normal CDF with these values, and we got 0.21, this 0.21 is actually the area under the curve. So that means that this is 21%. That is what normal CDF just told me. And so the expected frequency between 80 and 85 is 21% of my data. Now, 21% of my data, what is my data? My data is the number of family movies. And so my number of family movies, as we saw way earlier, is 200. So 21% of 200, 200 times this amount, right, the 21, there you go, 42.07. So 42.07, I count 1, 2, 3, round it up or keep it the same, you round it up. So 42.1, that is how you get it, see? So you find the percent, you multiply by the amount of movies, which is 200, and you get it, see? So for this next one, now that we understood what's going on, it's way easier. So for this one, I can go to normal CDF, say, okay, so my lower is 85, my upper is 90, my mean and standard deviation haven't changed. Boom, I got this percent. So it's 28% between 85 and 90, right? So I can say 200 times that percent I just got, and that is for my value of A. So your value of A is going to be 57.6274. Okay? If you really like significant figures, you count 1, 2, 3. Round it up or keep it the same. Keep it the same. 57.6. And for B, over here, notice how it's a T above 95. And so this is a little bit weird because you might be thinking, okay, so I'm going to put a lower for 95. But what do I put for upper? Think about it this way. You have 95 over here, and your upper is infinity. So it's any value of t that is above or equal to 95. So that means it's from this 95 to the right for your whole curve, okay, wherever it ends. But you don't know where it ends, right? And so here, all you really have to do is put a very big number for upper, see? So if this is technically just infinity, for our intents and purposes, you can just put an extremely big number and it'll make sense, see? So if you put an extremely big number that says, okay, you're going to capture all this area here until 99999, your curve probably ends like there. And so you're going to be sure that you accounted for like the last sort of tail, see? That is the game plan. That is what we tell our calculator. Our upper is going to be incredibly big. You press paste, there it is. So from 95 until the end, it's around 15% of your data. And so you can take this, multiply by 200, and boom, your B value. B value is 29.97. 1/8. And if you want to count significant figures, you say 1, 2, 3, round it up or down. Here you would round it up, so you actually end up with 30.0 for B. And that is for part E, part I. Now for part E, double I, we need to perform the test to a 5% significance level, okay? and clearly state the conclusion of the context, right? Now, which test are we doing? There was a buzzword way earlier that I didn't talk about much, which said chi-squared goodness of fit. And so right now, I need to open up my calculator and find chi-squared goodness of fit, see what it asks for, plug in, and solve from there, okay? And so technically, right now, I'm going to go to stat and test, because it's a test, right? And if I scroll a little bit, eventually, here it is, chi-squared goth. And so goodness of fit is for goth, see? Goodness of fit is goth, all right? So I press over here, and okay, it's asking for observed, it's asking for expected in my list, and DF. DF is probably the only weird thing that shows up for us, right? And DF is what they call degrees of freedom. And technically, it's really just the dimensions of your table, right? And so the table that I'm going to be putting is a bunch of lists, right? And so this list, how many guys does it, how many guys, how many numbers are you going to be putting? You're going to be putting 1, 2, 3, 4, 5. And so here you have 1, 2, 3, 4, 5, right? 1, 2, 3, 4, 5, yes. And so degrees of freedom, for our intents and purposes, for the IBAISL, degrees of freedom is going to be n minus 1, okay? I don't want to jump too much into it because it can get it a little bit confusing. This is the kind of thing I will suggest that you just sort of memorize. And so df is going to be n minus 1. And so if my n was 5, my degrees of freedom here is going to be 4. All right? Why would it be just n minus 1? Because it is a table, right? It is just one list. If it were a more extended table, the calculation for df is a little bit harder because you need to consider rows and columns, and it gets a little bit messy. See? For us, we're just going to worry about, okay, it's only rows, because you're putting one list at a time. It's only rows, n minus 1. Okay, and for us, TBH, it's pretty much always going to be n minus 1, right? For other math levels, maybe it's different. For us, it's just always going to be n minus 1. So, all of that being said, over here the df is going to be 4. And now for my lists, I'm going to put the observed and expected. Where did I put list again? I gotta go to stat, edit. Here are my lists. So I have the memory of a goldfish, which was expected, which was observed. Over here for the chi-squared goth, they tell us for the chi-squared goth, they tell us that okay, L1 is observed. See, so technically, if I go back here, observed is going to be L1, expected is going to be L2. All right. So okay, I go to my list. So L1 is observed, L2 is expected. Let's go ahead and plug in. So 11, 51, 68, 47, 23. And so the observed 11 has associated the expected 23.6. The observed 51 has the expected 42.1. The observed 68 has the expected A, which we said was 57.6. The expected 47 has observed 46.7. So that one is very similar. And for 23, we have B, which we said was 30. So now I can do the test, right? So now I can go to stat, test, chi-squared goth. Observed is list 1, yes. Expected is list 2, yes. DF, degrees of freedom, was n minus 1. I had 5 rows, so it's going to be 5 minus 1. Calculate. These are the values that I just got. And so my p-value, which is the most important one for concluding, right? So my p-value is going to be 0.016, 0.01646, whatever, 46. See, For significant figures, your p-value is going to be, you count after the zeros, you start counting. See, so from left to right, your first real numbers where you start counting. So it would be 1, 2, 3. So you round it up, or keep it the same. You round it up. So it would be 0.0165. That would be your p-value. Okay. So at a 5% significance level, do you reject or not the null hypotheses? From here, you have to compare the p-value to your significance level. What's the intuition of that? They are both percents. Okay, so you're comparing the 1.65% to the 5%. So 0.0165, is it more or less than 5%? So 5% is 0.05. How did I get that? I did 5 divided by 100. 5%, okay? Or as a decimal, whatever it's. Okay. So I'm comparing the 0.0165 to the 0.05. Which one is bigger? Clearly the significance level is bigger. And whenever the significance level, or think about it this way, whenever the p-value is smaller than the significance level, or whenever the significance level is higher than the p-value, you will simply say that there is sufficient evidence to reject HO. And so basically here you will be rejecting HO, right? Reject HO because of that, right? And so you have 1 point for answer for saying that you reject HO. You have another point for reasoning, which is saying this. You have another point for process or answer of your degrees of freedom. And yeah, that's pretty much most of that exercise for this last part. See? If you want more intuition on why this would mean rejecting, remember how I said that they're both percents, right? And so if you have the significance level, if it's significance level at 5%, you are looking for a percent that is even smaller. And so think about it this way. Your benchmark is at 5%. Anything better than 5% means you reject HO. See? It means that your data is like good enough, right? Why is that the case? Because if you had a percent that was higher than the significance level, imagine I got 7 or 8, that means, okay, that the data you did or the test that you did tells you like, okay, you were good, but you're not good enough. See, so to be good enough, you gotta be lower than the threshold mark. You gotta be lower than that significance level. See, and so because we're talking about probabilities, right? If we're talking about a critical level, which is like an actual value, you gotta be beyond that benchmark. See, in this case, you want to be smaller than that percent. If you're still confused, I'm gonna do a quick drawing, and that will finish this video, or this part of the video at least. And so technically, if you have a 5% significance level, it means that this last 5%, all right, you want to be within that 5% to the right. See, if you get, I don't know, 7 or 8%, that means you're around here. See, and so notice how it's a bigger percent, so it's more likely to get green than purple. You want to like ask your data to be like very rigorous, to be better than 5%. See, so right now we actually got 1%. So we got 1%, which is barely there. See, so 1% is clearly better than 5% because it's harder to get. See, it's more rigorous. You're asking more of it. See, so because your p-value is less than significance level, it means you're farther to the right on the curve, and it means there is sufficient evidence to reject HO because you're farther out than what HO expected you to have. HO has a certain spread to it, a certain variance, and you were beyond that variance. And so if you were beyond that variance at a 1% level, at a 1%, sorry, then that means, yo, your HO, like something's wrong. See? And so you reject HO. Remember that HO is the case of no change, right? Or no effect. So you're saying, no, there is an effect. See? You're wrong. You're wrong because I'm way farther out than what I should be. Okay? Being like in range means being in here. But at 1%, or better said, beyond this last 5% means, okay, you're like way out. See, you're way out. So, bada bim, bada boom, reject HO. Ladies and gentlemen, I was a little bit unclear in explaining part D, but I think everything else is pretty good for this video. If you have questions, leave them in the comments. Stay with the idea that the null is no effect, no change. All right? And intervals, yes, they're scary, but once you understand the mid thing, or that you can use cumulative, everything's a little bit more friendly. See? There's always ways to make exercises more friendly and problems in life in general. Ladies and gentlemen, I hope it helped. I'll see you around. All right, and now for number 4, our good old friend Ruben. Okay, our good old friend Ruben wants to buy a car for a price of 285,000 South African rand. In other words, their ZAR. Okay, I hope I said that correctly. If not, sorry. He goes to a bank to get a loan. Okay, this is very important language here. To get a loan to buy a car. To be eligible for the loan, in other words, for the bank to say, yeah, sure, Ruben must make an initial down payment equal to 25% of the price of the car. Alright, guys, this is a classic. Happens in real life all the time. Imagine you want to buy a house and the bank says, sure, but first pay half of the house. Or first pay 10% of the house. Now, how the percents actually are, how they work, how they calculate them, it's a mystery. I don't know too much about it. But the idea is you have to pay some of it up front. Okay, so that is why they mean by initial down payment, you have to pay a little bit up front. You have to pay a little bit right away. In this case, our good old friend Ruben has to pay 25% of it right away. All right, and so the bank, if Ruben decides to do this, the bank offers him a 5-year loan for the remaining balance. So first he pays, and there's for the remaining balance, he's going to have to pay back at a 4.5% nominal interest rate per annum, compounded monthly. And so here, there's so many buzzwords, man. It's crazy. But we'll go piece by piece, okay? And then, even here, there's key information. Ruben will pay the loan in fixed payments at the end of each month. At the end of each month. And so for part A, part I, we need to find the original amount of the loan after the down payment is paid and give our exact answer. All right, so there's definitely a couple of things going on here. Let me give you a little bit of context. Okay, for part A, part I, we don't need too much context, right? So for part A, part I, it's the OG amount of the loan after the down payment is paid. So first we need to find the down payment. And so the down payment would be the 285,000 and 25% of it, right? So this times 25% is going to give you how much he needs to do for the initial payment. And so the initial payment is going to be this 285 times 0.25. So this is his initial down payment, right? The 71,250. So that means that of the 285,000, he immediately does the down payment of 71,250, which gives him yada yada yada, bada bim, bada boom. That amount. So in other words, for part A, part I, you would say that after the down payment is paid, our good old friend Ruben owes the bank 213,750 ZAR. Some of you guys might be thinking, there's a quicker way to do this. If you take the 285 and technically you need to take that 285 and do minus 25% of it, right? And so technically you can take the 285 and do 1 minus 0.25, which gives you the 285 times 0.75. And so yes, technically if you find 75% of the 285. It's the same as getting the total and doing minus 25%. So this, you can change it to 0.75 and you get the same answer, okay? I'm just mentioning it because I know some people like to think that way. So you either think about it as, if you're getting rid of 25%, you can immediately find 75% of your original, or you find the literal number for 25% and subtract that from the original amount, okay? So whatever floats your boat, those are two ways to do it. I think this one is more intuitive, but this one on the bottom is also faster, so I get why some people would aim for that. Whatever, enough blah blah, that is A part I. Now it gets juicy, and now is probably why you clicked on this video. And so for part A, part double I, we need to calculate Ruben's monthly payment for this loan to 2 decimal places. And so here there's a couple of things we need to give the context for. First things first, you probably already identified, this is a finance problem. And for finance, you have two main tools. One of them is the finance app, and the other one is the formula on your formula booklet for compound interest. Now, you have two different tools, and although they are very similar and technically the finance app is the formula for the compound interest, we need to acknowledge something. Whenever, yes, literally, whenever you have something about end of each month, which is going to be associated for PMT, okay? Whenever you have PMT, the only tool you can use is the finance app, okay? And just to show you guys quickly, if you go to the formula booklet and you look up compound interest, you can see that there's a bunch of stuff here that we can try to use and almost use, right? For example, they have FV, they have PV, R, K, K times N, right? And so the finance app, if I go over here, the finance app has a lot of this. So for the finance app, you press apps, then finance, then the TVM solver. And so here is pretty much anything, except that additionally, they have PMT. Interesting. So PMT is the payment per month, or the monthly payment, if you want to memorize it like that. And the compound interest formula that they give you is no PMT. You have no PMT here. And so this formula only works if there's no PMT. So that is difference number one, the no PMT thing. Difference number two is that on the finance app, you have an N, and for the compound interest one, you also have an N. But careful, on the finance app, you have big N, and on the compound interest one, you have small n. And yes, there's a difference. The difference is that big N is k times n. And so k times n gives you big N, okay? So big N is k times n, and little n just stays as n, okay? Now, I need to make a big disclaimer here because I'm sure some of you already disagree with me. The big disclaimer is that the method I will suggest for you to do takes the perspective that big N is k times n, okay? If you look at the answer key, which let me just bring it up over here, just so that we all agree on this. If you look at the answer key, you can see that for this question, number 4, sometimes you have what they say method 1, and then you have what they say is method 2, okay? And so within this, all right, sometimes n will have to be 1, big N, and sometimes big N will have to be 51. I guess there's better examples for this, but the idea is the same. Like, there's more than one way to use the finance app, okay? And the way that I will suggest for you to use it is from the approach that big N is k times n, okay? So I will explain all of it, assuming that big N is k times n. There are ways for you to use the finance app and take big N as small n, but for me, that is a lot less intuitive, okay? So for each their own, this is just a disclaimer. For me, for what's coming, big N will be k times n, okay? Why do I do it this way? Because then these two values at the end, the p and c, can be the same. So when big N is k times n, this py and this cy can be the same. And the moment that you say that big N is equal to small n, that means that the py and the cy are now not equal to each other. And for me, I'd much rather remember big N equals k times n and that these are the same rather than have the extra headache of trying to figure out what is py and what is cy. Okay? So I know that is a lot of blah blah. I just want to leave really clear these mark schemes can get confusing. There can be more than one method, and the difference of methods at the end of the day is what you choose big N to be. Okay? So for me, big N is going to be take k times n, deal with it. That's how I'm going to do it. All right? Sorry for the long monologue, but I think it's very relevant to explain that. And so here, for part A, part I, you need to calculate Ruben's monthly payment for this loan to do decimal places. And so if you're trying to find the monthly payment, you are trying to find PMT. We already said that at the end of each month, our monthly payment is going to be PMT. So that means in this solver thing, I'm going to put everything as 0, okay, just so that we understand our approach. So everything will initially be 0, and we gotta, whoops, I'm gonna make these 1 because of domain. And I'm gonna show you how I fill everything in. And so I said that big N, the first thing I have to plug in, so big N, I said was k times n. Now what is k, what is n? K, as it says here, is k is the number of compounding periods per year, while n is the number of years. Oh, okay, so n is number of years, k is number of compounding periods per year. Here they tell me that it is compounded monthly. How many months are in a year? 12. So k is going to be 12. Little n, we said, was number of years. What are the numbers of years in this case? It's a 5-year loan. So little n is going to be 5. K is going to be 12. That means that big N, which we said was k times n, is just going to be 12 times 5 is just going to be 60. So big N is 60. This I%, as we can see here, is the nominal annual rate of interest. So basically, your rate of interest. And here they say 4.5% nominal interest rate. Some of you might be freaking out by the fact that it says nominal interest rate per annum, which sounds incredibly fancy, but per annum, it's like per year, which is, well, look at that. Here it says annual interest rate. And so this annual interest rate is like the annum thing that for some reason at the test, they want to get mean with you and say per annum. Whatever, dude. 4.5% is the same R as this one, nominal annual interest rate, okay? So here I can put 4.5 as it is. I'm sure some of you are thinking, but Mr. or a random guy on YouTube that I'm watching 10 hours before my exam, why is this not 0.045 if you're telling me that it's 4.5%? And I say, nuh-uh, watch on the left side there, it says I%. So this number is already as a percent. So when you say 4.5, you're saying it's 4.5%, okay? In fact, if you put 45, you're saying it's 45%. If you put 66, it is 66%. If you put 4.5, it is 4.5%, okay? So that's with that, PV is going to be your present value. Now, because it is a loan, and I'm going to try to explain this very well because a lot of people do questions with this. See? So think about it this way. It's a loan, right? It's a loan. So that means you asked money from the bank, right? And so our good old friend Ruben, if it was a loan, does he owe money to the bank or does the bank owe him? Does the bank promise to give him back money later? Nuh-uh. Ruben got a loan. He's in debt. Ruben owes money to the bank. So think about it this way. If you make a number line, okay, and you call this 0. All right, so here's a number line. Here's positive infinity. Over here's negative infinity. If you think about it, our good old friend Ruben right now owes the bank 21,000 to 21,000 213,750 ZAR. So that means right now he has negative 213,750 ZAR. And so your PV is here, and through a series of PMTs, which are adding, so through a series of plus PMTs, I don't know how many, but through a series of positive PMTs, he's going to reach 0. And that will be when he has paid off his loan. And so this also tells me that 0 is going to be your future value. Our good old friend Ruben has a crap ton of debt. He needs to pay monthly a bunch of times until he does not owe anything, until his FV is 0. And so part A, part double I is how much PMT is he paying? Alright, so this right now just revealed that your PV is negative 213,750. Notice PV is negative. Yes, PV is negative because it's a loan. So because it's a loan, you have a negative PV. Okay? He owes money, he has negative money. So that is my PV. PMT, I have not figured it out yet, so I'm going to skip it. FV has to equal 0. Okay? And one last thing that I forgot to mention is that PY and CY, with my method here saying that big N is K times N, PY and CY is just going to be K. And so for me, that method of approach is way friendlier. PY/CY just has to be K, as long as big N is K times N. So, that being said, PY/CY is going to be K. We said earlier that K was 12. Remember that K is how it compounds. So K is number of compounding periods. Because it's monthly, K equals 12, so you can put both of them as 12. PMT end or begin, I always see end. So whatever, dude, just leave it as end. I've never had to use begin. And now you can solve for PMT. Now you might be thinking, what the heck? How do you solve for PMT? Where do I press enter? And I say, here you have a solver. It's a little bit different. So basically what you're telling your calculator is, using all this information, what should my variables be? And so using all this information, solve for just PMT. Where is your solve button? Right above enter in green. So to hit that green button, you press alpha, enter, makes you hit solve, boom. Right there, you solved for PMT. And so part A, part double I is going to be 3,984. We can round it a little bit, of course, to 95. Don't forget your units, ZAR. Okay? So that is what just happened. Okay? That is part A. Then for part B, you need to use your answer, okay, from part A double I, so basically use your answer from just part A in general, to calculate the total amount Ruben will pay over the life of the loan. To the nearest ZAR, do not include the initial down payment. Do not include the initial down payment. All right, so I know this part might be a little bit confusing, that do not include. But basically what it's saying, okay? Basically what it's saying is that Ruben already paid the initial down payment, okay? And what he has to pay right now is just what he owes the bank, right? So in other words, what it's asking you is, okay, all these PMTs he had to pay, what is the sum of all of these? So if you do this one plus this one plus this one plus this one plus how many times it has to happen, how much is that amount? And so the big question here is, how many months did our good old friend Ruben have to pay? All right, we know that Ruben, right, pays pays monthly, right? So that means per year he pays 12. So he paid for 60 months because big N, big N is 60. So all you really have to do here is take your PMT and multiply by number of months or periods or whatever. And so here you would have to be doing your answer from part A double I, so 3984.95 times 60, which is your number of months. Okay? So if you go ahead and do that, you will end up with this 3984.95 times 60. There it is. 239097. And because it's to the nearest star, right, you want to make sure it's 0.0, right? So round it as 0.0. Here we got exactly a number that's already rounded. See, so we can just leave it as this. And that would be for part B. Now it gets a little bit more exciting. Well, I mean, I think it's already exciting, but that sounds a little bit nerdy. Here it gets exciting because they tell us that Ruben would like to repay the loan faster and increase his payments such that he pays 4,600 ZAR each month. Part C is find the total number of payments he will need to make to pay off the loan. And so here, what the IB really loves to do is basically, for the finance app, if I look at it now, you filled in all this information. And so what the IB likes to do is like throw you like a curveball. You know, they throw you like a curveball and they change one of these variables up just a little bit. And so what you need to do is know how it changes. Okay? So think about it this way. He wants to repay the loan faster, okay, and increase his payments such that he pays 4,600 ZAR each month. Now, I did mention that each month was a buzzword. In fact, I mentioned it for up here at the end of each month. So we're talking about our PMT. So PMT used to be around 3,900. Now our PMT, they tell us, is 4,600. So clearly, he's paying more per month, so his loan should get paid faster. There should be less months in it. Okay, that makes a lot of sense. Imagine I owe you $10 and I say, okay, every week I will pay you $1 back. I'm going to take 10 weeks to, pay back the $10. And now imagine that like midway through I'm like, you know what? I'll start paying $2 per week. Of course it's going to be faster. Of course it's going to be less weeks. And so here, in a much more complicated way, the IB tells you, all right, our good old friend Ruben wants to pay his loan faster. How would this affect the amount of time or the amount of monthly payments? Blah, blah, blah. And so the total number of monthly payments would have to be big N. That's also the other thing we have to identify. We don't know what big N is anymore. Big N is now going to be our X. This is what we need to solve for. And so you can take this calculator thing and you don't know what N is, right? So I'm going to leave it as 0, okay? Just like a placeholder, big N is 0. That's what we're trying to find. Now what changes? I still have the same percent. I still have the same amount of money owed, okay? And PMT is what changed. So PMT is going to be 4,600. PV is still negative because it is a loan. PMT is going to be positive because you still want to reach an FV of 0. So really, it's like the same diagram that I drew here, just that your PMTs are going to be a little bit faster. So it should be less PMTs in order to reach an FV of 0. So it's a stronger PMT, okay? And that means that big N changed. So you plug everything in. K is still 12, so these are still 12. You solve for N. Alpha enter to hit solve. Big N is that. And so big N is going to be 51.153. Now, here's something interesting. At n equals 50, does he pay off the loan? At n equals 50, technically he does not pay off the loan because he still owes just a little bit. And so, because of context, your final answer has to be that big N is 52. What's the intuition of this? Let's go back to the example of I owe you $10 and I pay $1 per month. See? Imagine that I increase my payment to whatever, like $1.50. Okay? And so imagine that on the last month, I owe you 50 cents. Okay, I owe you $0.50. And so even though I am paying you $1.50 per week, the last month I owe you $0.50. And so I can't just say, dude, it's $0.50, I'm done. No, man, I still owe you $0.50. And so even if it's a small decimal, even if it's a small number, I still need to finish off paying the next week. Okay, so you finish off paying the next week, your answer is going to be big N equals 52. All right? Awesome. So that is for part C. Big N has to be 52. Then they tell us that this strategy will result in Ruben's final payment being less than 4,600. Why would it be like that? It would be like that because our good old friend Ruben, okay, wants to pay in like the exact amount, okay, wants to pay in the exact amount of months. He doesn't want to owe $0.50. He wants to pay everything like perfectly. Okay, that's the idea. He wants to pay everything perfectly. And so, I mean, let me rephrase this a little bit, okay? That means that the moment he reaches the last month, he paid extra. Okay, that is a way better way to do it, to put it. Forget what I said like 10 seconds ago. Because we're saying that big N has to be 52, that means that he will end up paying a little bit extra. Okay? And so the other way you can think about it is how much did he pay at N of 51? And so how much did he pay at N equals 51? And then add just that small amount that's left. So basically, back to the example of owing like 50 cents or $0.50 at the very end, well, you first have to figure out that it was $0.50. And so, how much will he pay extra or not? Blah, blah, blah. That's what we have to figure out. And so, we need to determine the amount of Ruben's final payment to do 2 decimal places. So, technically, from here, you can put a big N of 51. Okay? So, this is just right before, okay, we have our final amount. And so if you make a big N of 51, so you make big N equals 51, and everything else remains the same, we can find, okay, we can find a new FV. Because let's understand, if I solve for FV from here, I am asking my calculator after 51 periods of paying 4,600 per month, how much future value I am yet to pay. This is like the $0.50 we're trying to discover, okay? And so if you use solver here, and you get this amount, and so at N equals 51, we got an FV of 704.156. Okay, this is very important to understand. So one before the last month, good old friend Ruben still owes around 704 ZAR. But per month, he pays 4,600. And so clearly, 4,600 is way bigger than 704. And that is why you have a decimal here of 0.153. Okay, that's the 704 that we're talking about. And so now, this was for the 50 from 0 to 51 months. And now I can calculate month number 52. And so for month number 52, to make Ruben's his final payment, you need to plug in values in a pretty special way. So because we're talking about just 1 month, big N is going to be 1. Your percent is still the same. Your present value is how much you owe at this last month, so it's going to be 704.16. Your PMT is what you're trying to find, and you want your loan to equal 0. This is my value of K, so it stays as 12, right? And so I know that I said that big N equals K times N, but with this context, you only want to find the last month, so big N will be 1, okay? A lot of times, by context, big N has to change, and that's the name of the game, understanding when this changes, how that works, etc. This is a very special scenario where you only need to calculate for 1 month, for month number 52. And so for that, you plug in your values like this. Let me go over it one more time. So big N equals 1 because it's only month number 52. Your percent is the same because they have not changed your percent. Your PV is 704, which was the FV of N equals 51. So that means at the end of month number 51, Ruben still owed 704 ZAR. And so from month 52, you put 704 ZAR as present value, and you need to see how much you need to pay monthly to reach 0 for FV. So how much he needs to pay monthly in order to get basically in order to pay off the loan with FV equals 0. See? So you find PMT from here. So now I can do all the solve functions. So I press alpha, enter, boom. There it is. And some of you might be thinking, what the heck? Why is it not just 704.16? And I'm going to say, it's because the bank earns money. And so for the bank to earn money, they're going to charge a little bit more. That's why you have the percent over here. That's why it's just a little bit more, right? So yes, he owes technically 704, but how much does he have to pay? A little bit more because the bank earns from percents and stuff, see? And so from here, for month number 52, we found that the PMT of that, right, was 706.80, right? Here it gave it to me negative because I forgot to put a negative PV over here. So technically, if I go back to how I was always doing it, our good friend Ruben still owes negative 704.16. So you find the PMT from here. That makes a little bit more sense. See? So apologies for that. I forgot to put a negative PV. Why negative? Because we're talking about a loan. So that is that. See? And so so for part B, the amount of Ruben's final payment to 2 decimal places is the value of this PMT. See? And so to 2 decimal places, your whole number was 706.8006. So 2 decimal places, you count 1, 2. You want to round this number. So do you round it up or keep it the same? You keep it the same. So 706.80 will be your final answer for part D. And last but not least, for part E, we need to determine the total amount Ruben will save to the nearest SAR by making the higher monthly payments. So the whole point of making higher monthly payments is that he needs to pay less months, and if he needs to pay less months, then that means that the bank charges less interest. How would it charge less interest? It charges less interest because each month they charge a little bit, right? And so if there's less months going around, there's less interest they can charge. Intuitively, that's the main idea. The real world is a little bit different, but let's leave it at that, okay? So, for part E, he's making the higher monthly payments. And so when he did the higher monthly payments, how much was it? When he did the higher monthly payments, we were talking about 4,600. So that's the first thing I'm going to write down for part E. We have the 4,600 per month. Now, for how many months did this happen? For 51. So he did it for 51, and at the very end, he had to pay 706. In other words, for 51 months, he paid 4,600, and at the very end, he had to pay 706.80. So more intuitively, you can think about it as this is from 0 to 51 months. And over here is the 52nd month. Okay? So if he pays like this, he ends up with 51 times 4,600 plus 706.8. So this gives me that number, 235306.80. So this is the amount that our good old friend Ruben would pay if he decides. So this is and ZAR, right? So this is for the higher monthly payment. Higher monthly payment. So if he pays for the higher monthly payment, this is how much he pays in total. So this would be his new total with higher monthly payment. But part E is asking how much will he save because he chose to pay the higher interest. And so with the context of the problem, in which part was he paying with the lower amounts per month, right? Everything before this. So everything before this paragraph is going to be less, right? And so right before this in part B, I know this is like scratched all over, so let me erase a little bit. So for part B, we were saying the total amount for the life of the loan, and in which context it was for a monthly payment that was a little bit lower. And so technically I need to compare what I just got with part B. So what I just got with part B, okay, part B is being this number here. So I can take the 239,097, if I recall correctly. So this guy here, so basically part B. So you take from part B, right? You subtract it from what you just calculated using the higher monthly payment. And that is, ladies and gentlemen, the difference, or how much he saves by doing the higher monthly payments. More intuitively, think about it this way. This is the lower monthly payment, so the lower PMT, and this is the higher PMT. Okay, so using lower PMT, he pays this total, and using higher PMT, he pays this total. Clearly there's a difference. Clearly there is some amount he saves. And so here, it's to the nearest czar, okay? So you want to keep the numbers nice and rounded. Let's go ahead and show what happens. So from here you have the answer from part B, so the 239,097 minus what I just calculated, right? This gives me the 379.2. 3790.2. Now, because they wanted to the nearest czar, which one is the nearest czar? The nearest czar, you take this number, you say, do you round it up or keep it the same? You keep it the same. So the nearest czar is actually 379 as is. So for part E, it will be this number here, okay? Guys, I think this is a very good exercise to understand the finance problem like at its depth, because everything gets thrown at you. See, like almost everything that can happen gets thrown at you. It's a loan problem, which is usually weird. And so the intuition I want to share with you guys is that when it is a loan problem, PV is negative, okay? PV is negative when it's a loan problem. If it's a problem of like good old friend Jimmy puts $100 into his savings account and wants to see how much he earns like down the road, right? Like 5 years later, then it's not exactly that PV being negative and stuff like that. Then it's a little bit different, okay? But because of context, there's a couple general rules you can draw from this, okay? The method I like to suggest, as I said, is that big N is K times N. It just keeps it a little bit more clean because that way PY and CY is just K. It's not as confusing as the other method, in my opinion. And the other thing you need to consider is, okay, so it's a loan, so you're going to be putting a negative PV, a positive PMT, until you reach FV of 0. So that is another interesting thing. FV equals 0 because we're talking about a loan, all right? And why did FV change near the end? It changed near the end because on month 51, he was going to have to pay a little bit less, okay? Because at the end of month 51, he almost paid everything. He almost paid everything. He just needed to pay month 52, but month 52 was less amount than the monthly payment, so you needed to recalculate that, okay? Including the percent, including all that stuff, blah, 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 okay? Ladies and gentlemen, this is a hard one, but I hope I helped, and yeah, hope this helped. I'll see you around. That is for number 4. All right, you guys, number 5. I think number 5 is pretty hard. So put on your seatbelt and, good luck. We have that Mosaic Industries is an international company that sells cell phone cases. Their market research predicts the average number of cases they will sell each month is modeled by the equation blah, okay, where X represents the selling price and euro for each case. And N, of course, is going to be the average number of cases. And so let's first understand that N is going to sort of be like number of cases, and X is going to be the selling price. So for part A, we have that a salesperson suggests that Mosaic Industries should sell the cases for 60 euros each. And so clearly this is going to be an X value, okay? We need to find the average number of cases, so you need to find an N for part A. You're going to find an N that this model predicts Mosaic Industries will sell at this price. And so pretty straightforward for part 5A. This exercise is still relatively friendly. For part 5A, you need to plug in on your function N, you're going to plug in an X of 16. So in other words, you will be asking your function at this point, when X is 16, what is N? When each case is sold at 16 euros each, what is the number of cases that get sold? So N equals the 20,000 minus 1,000 times 16, right? And if you plug all of this into your calculator, you're going to see that 20,000, whoops, you see that 20,000 minus 1,000 times 16 gives you 4,000. So N equals 4,000, all right? So 5A, we're going to say that at this price of 16 euros each, N equals 4,000. And for part B, we're going to calculate Mosaic Industries' average monthly income before expenses at this selling price. And so monthly income is a little bit like money earned, okay? And so money earned is just going to be each phone is being sold at what price? At 16. And how many phones are you selling? 4,000. And so for part B, all you need to do is take the amount of phones that you have, multiply it by the price that you're selling them, and that will be your average monthly income. Now I'm sure that some of you econ nerds out there might be thinking, okay, but there's a cost associated to this. And I say you are absolutely correct, but this exercise still doesn't get nasty. We are still before any expenses. And so all you need to do is just take the brute amount of cell phones, multiply it by the price that they give you, and that will be your profit, or better said, your monthly income for now. Profit includes costs, so for now it's just income, right? So your income is going to be the amount of cell phones, 4,000, times the price that you sell it at, 16, and there it is. So your average monthly income for part B will be 64,000, all right? Now let's recall that all of this is in euros, all right? And then part C, they tell us that hence, so because it's hence, you need to use everything from before, so that's good. Write down the function Rx. Okay, that sounds horrible. Write down the function Rx that can be used to predict Mosaic Industries' average monthly income before expenses at any selling price X. Now notice, technically what they're saying is like, okay, so what you did for part A and part B, give me a function that I can always use. So what did we use for part A and part B? On the one hand, you found an amount with n, and then you multiplied it by the amount of by like the price and the amount of stuff that you had, like etc. Right? And so technically, all I really did, was that this n, okay, this n, I multiplied it by my price. Okay, technically, I found an n of 4,000, and then this n of 4,000, I multiplied it by my price, correct? So technically, Rx is just going to be your price x times your amount n, right? But n, okay, n we said was this. And so really, Rx is going to be x times 20,000 minus 1,000x. And why do we need to leave it like this? Because they want it to be in terms of x, right? They want you to write down the function r of x at any selling price x. So you only need x, you do not care about n, but n is technically like this whole thing here, right? Like, whoops, my computer just went crazy. So technically this n here is this whole thing, right? And so you plugged it in just to have it all in terms of x. This is one way to answer. This gives you the point, okay? Maybe for you it's more friendly if you distribute the x right away. Maybe down the line for you makes more sense. You can also write r of x as 20,000 x minus 1,000 x squared, okay? So both of these work, to each their own. That is for part C. Now it starts getting a little bit more nasty. Now it's the part where you say, okay, yeah, paper 2 is crazy, like, what is going on? And so here they start telling us, that Mosaic Industries has 10,000 euros of fixed operational monthly costs. Additionally, Mosaic Industries must pay their phone case supplier 10 euros for each case. And so when you calculate Mosaic Industries' average monthly profit, so notice how now we're talking about profit and not income like before. Now we're talking about profit if they sell each case at price of 16 euros. So guys, unfortunately, you do need to know the following detail. Income is like before costs. Profit is after costs. So it's very easy to have a positive income, but sometimes it's very hard, to have positive profit. And so profit, you need to acknowledge these costs. And they tell you that on the one hand, there's a fixed monthly of 10,000. And on the other hand, you need to pay your case supplier 10 euros for each case. And so you need to express all of that, okay, for part D. And so one way to do this, which I think is the most friendly one, is that you can do your income minus your costs, which gives you your profit. Okay? And so I already have a function for income from part C. And so income, I can already call it, there's not a lot of space here, but whatever, I can do it up here. So we have, you have income minus costs will give you your profit. And I already know from part C that I have a function for income, r of x, right? And your costs, I'll do them at the end. Okay, so for now, let's just focus on plugging in Rx correctly for now, right? Now, because we're still selling at 16 euros, I will be looking at R16. Okay, it's going to be your income when you sell it at 16 per phone. And so Rx from part C, we said it was this, correct? So technically, I can put up here an x parentheses 20,000 minus 1,000 x. And all of this, I still don't do minus costs to get your profit, okay? So if now I'm going to focus on plugging in for costs, see? So this right here is just going to be my income on the left side. And now for costs, well, on the one hand, you have 10,000 of fixed monthly, right? Now careful, all of this is in monthly. So all of this is in monthly terms. It's not that you need to multiply by 12. It's not that they're asking for how much you earn per year. All of this is in monthly, okay? And so think about it as just a fixed operational cost, okay? The word monthly here doesn't really matter, okay? Each month, it's filled with monthly. So it's all in terms of monthly. Don't be scared by the word monthly. Basically, one of the costs you have is a straight up amount of 10,000, period. So straight up, one of your costs is 10,000. And your other cost, which is why I'm going to be doing it negative, because you're subtracting from your income, you're losing money. So one of them is this fixed 10,000. So I'm going to actually put up here just so we don't forget. So this is fixed. This right here is just income, this whole thing. And the other one we need to do is the per case. So they tell you that they must pay their phone supplier 10 euros for each case. So technically, here I can put you pay 10 per case, 10 times n. And so this will be your, if I get very fancy, it's variable, right? So it's your variable cost because it's what changes. But for us, to keep it clean, to keep it more friendly, we're just going to put per phone. Per phone cost. Okay, so here I have fixed cost, over there I have per phone cost, and over there I have income. So now it makes a little bit more sense to work with this. All right, guys, earlier we said that we wanted to have it all in terms of x and not n. What did we say n was? We said that n was this. And so now my income, well, stays the same. Your fixed cost is literally right there. And your per phone case is 10 times n. N being 20,000 minus 1,000x. So all of this is your profit, all right? And now what is your x value? Well, here, and actually just to leave it very clear, so this whole thing on the left is income. So all of this is income. This is the fixed cost. And this last part is the per phone cost. So now if I plug everything in with a certain x value, I get the profit at that level. And so from here, what is my x, right? Well, x, we are saying in this context that x is your selling price. So you have selling price x. At what price are you selling? At 16. That's why at some point I said that your r has to be 16. Now technically, everything is 16 because x equals 16. So you plug in x equals 16 for everything, so you end up with 16 times 2,000 minus 1,000 times 16 minus 10,000, which is your fixed cost, minus 10 times 20,000 minus 1,000 times 16. Now, I know some of you are looking at this saying, dude, this is crazy. This is such a long equation that is so annoying. But if you take it piece by piece and you start thinking about, okay, on the one hand, I have income. On the other one, I have my costs. It's a lot easier to face, okay? So go piece by piece. You might end up with like a crazy long equation, but if you follow the process, it's fine. And all of this, ladies and gentlemen, comes from this first line. Okay, so this first line, income minus costs equals profit, is key to make this a little friendlier. All right, and I've actually noticed that there's quite a few exercises that tend to show up that talk about profit, talk about income, talk about costs, so might as well get to learn it a little bit. Income minus costs equals profit, period. Start from there, follow through, it'll work. So all of this I can plug into my calculator. See, I could plug in piece by piece, but that is annoying. So I'm just going to plug in everything because that is how I am. So over here I can say this first parenthesis is 16 times 2,000 minus 1,000 times 16. Close parentheses, minus your fixed cost, which we said was 10,000, minus 10 times 20,000 minus 1,000 times 16. Close, close. This is the profit that I am getting for part D. Now here, I think I have something fishy going on because I just ended up with a negative value. So give me a second. I'm just going to double check what I plugged in, right? So let me double check. I don't think it makes sense that this is negative, but let's see. So here on the right side, looks clean. It's times 10 minus 10,000 looks clean. Minus 1,000 times 16, close parentheses. It also looks clean. All right, I think I just realized where I messed up. So sorry for the long, awkward pause, but I think it's good to include in the video anyways, because it's a little bit more real. If the day of the test you plug in and you get a negative value for profit, it can be correct because maybe the guy is putting in the wrong price, and he's actually not earning money, so he shouldn't be doing that way. But I just realized, notice here where I plugged in for n, right? So here I plugged in for n, so all of this is n, all of this is n. Careful, for n, right, this is 20,000. So how come I have 2,000 here? Because this was for income. And so for income, there it is. For income, small detail, but here I have 4 zeros, and here I passed on to 3. So there I trolled a little bit. I missed a 0 here, I missed a 0 here, I missed a 0 here. And now my numbers should make a little bit more sense. So let me plug it in again. I'm keeping it in the video because I think it's amazing when you guys see where I commit a mistake. Because we all make mistakes. It is nothing to be ashamed of. And it also shows that if you ever get an answer that's a little bit weird, take a moment, double check. Take a moment, double check, and might as well, right? And so I double checked. I realized I was missing a 0. If you realized earlier, nice. If you didn't, don't worry. There it is. This makes a little bit more sense. It's a positive value, so I'm going to trust it a little bit more. I'm glad I checked because clearly I was missing a 0 for the income. See? So anyways, that is for part D. So for part D, you would say that the profit equals 14,000 euro. All right, so that is for part D. Now for part E, we're going to show that the average monthly profit for any selling price, X, can be found using the function blah, blah, blah. Now, this is for profit, right? And technically, I also have an equation for profit. And so this line here is where I plugged in for profit with an x equals 16. And so we need to show that this right here, which is an equation for profit, is also what they have down here with negative 1,000 x squared plus 30,000 x minus 210,000, right? And so from our equation of profit, we need to reach this equation of profit. Why is that my approach? Because it's a show that exercise. Whenever you have a show that exercise, this is true. This is the profit equation as it should be if you boil it down a lot, right? If you like work through it a lot, etc., right? And so up here is like my profit function, but it's not yet developed like fully, right? And so if I develop it fully, I should reach what we have in green. And so from here, let me take a moment and try to develop it fully. And so from here, you can say, for example, this, actually, let me just rewrite it. Or actually, no. So for this income, I'm gonna distribute the x, right? So if I distribute the x for income, I will have 20,000 x minus 1,000 x squared. So this is my first parentheses, see? For this second one, I have fixed cost, which is not going to change. It's just going to stay there. And for this last parentheses, I have this times this and this times this. So 10 times 20,000 should give you 200,000. But just so you trust me, because I am a guy on the internet, and you shouldn't trust guys on the internet, here it says 200,000. So I can have minus 200,000. So that was this jump here, okay? And then minus 10 times negative 1,000 should be 10,000, but let's check. All right, and here I have plus 10,000x, right? Why is it plus 10,000 and not negative? It's plus because here you're multiplying by negative 10 times a negative 1,000 here. And because I'm a boomer and I didn't realize, there is a times 16 going around here and here. So yet another mistake for you guys to look and laugh at. So technically this first number here should have been or actually wait, I'm trolling. Wait, I'm trolling. That 16 was when we plugged in x equals 16. No, I'm fine. I haven't said anything. I was looking at the wrong side. I'm sorry. But still, this would be plus 10,000x because it's a negative 10 times a negative 1,000. So negative times negative gives positive. All right. Sorry, guys. I think I'm not very concentrated this week in general. But anyways, so you just distributed x and you want to reach what's in green, right? Now what's in green is all nice together and combined and etc. So we're going to do that now. For example, I can combine, let's focus just on x squared for now, right? So just x squared is only this one. So I'm going to leave x squared up in front for now, all right? So I'm going to leave x squared up in front for now, all nice and alone. And later on, right, and now, later on, I can now combine the x's, right? So I can combine, for example, this x and this x. And so you're going to have 20,000 plus 10,000x plus 30,000x. And last but not least, you can combine these two. So you can do the negative 200,000 minus 10,000. So that gives you minus 210,000. And from here, I can check if I got the same thing that's in green, and it looks exactly the same. And so for the show that, for part E, the show that, like strictly speaking, for part E is going to be what I am putting now in yellow. So for part E, it's technically all of this. This is part E. Okay, that is part E. So this is for showing your work for part E. This is part E. Okay. Anyways, we ended up reaching the same sort of equation. So that is what we will be using for profit. So that is for part E. We check it. Part F, immediately, we see that it has two parts. And whenever it has two parts like this, it means that the second one depends a lot on the first one. Okay, a lot of times, I don't know, part E needs something from part F and stuff like that. It's not always the case, but it is always going to be the case that part 1 is needed for part 2. All right, so that is already a big hint for what's coming in front of us. And here for part F, part I, part 1, we have find the derivative of px. And so how do I know it's the derivative? It's because you have this symbol. And any of you that just thought, isn't that the inverse? Inverse would be if they write it like this. Derivative is if they write it like this. Okay, so it's the difference. Here you have a minus 1. Here, technically, it's like an apostrophe. Okay, so this one is going to be for the derivative, and this one is going to be for the inverse. All right, so there's a small difference there. Know your differences. All right, you guys. So the derivative for the IBA ISL level, if I put it into my formula booklet, you have this one, which is the derivative of the exponent. So you can look it up. I actually have a video on it. You can enjoy your time there. There's a bunch of other derivatives, but this is for HL, so we can just, laugh at them. Anyways, we only care about derivative of an exponent. And so here, I know it looks a little bit weird, but really, really focus on what n is doing. So n, first of all, multiplies in front, and second of all, it gets a minus 1. In other words, x squared is going to be 2x, because it went in front, and then 2 minus 1 up top. Derivative of x squared is just going to be 2x to the power of 1, which you leave it as 2x. But mister, what happens if there's a fraction? What happens if there's a number in front? 3x squared is going to be 3 times 2 times x to the power of 2 minus 1. So it's going to be 6x to the power of 1, the same as just 6x. What if there's a fraction or whatever and blah, blah, blah? Okay, 1 over 4 times x to the power of 8, Let's go crazy, to the power of 8. So derivative of this is 1 over 4 times 8 times x to the power of 8 minus 1. And so from here, you're going to have 8 over 4 for the fraction times x to the power of 7. 8 over 4 is the same as 2. Derivative of this is that. All right, there's a lot more examples in the, or better examples in the video that I have for derivative of an exponent, but for our intents and purposes from here, if you do derivative of p of x, well, this first term, right, you're going to have negative 1,000 times 2 times x to the power of 2 minus 1. For this next one, you're going to have 30,000 times 1, because technically x to the power of 1, you know, the 1 has to go down, right? Times 1 times x, that was a nice voice crack, times x to the power of 1 minus 1. And this last one is technically 10,000. If I get very, very technical, it's going to be 10,000 times 0. Because here you have an x to the power of 0. And so I'm just going to leave it at that, right? X to the power of 0 times x to the power of 0 minus 1. If you get very technical, here there's a hidden x to the power of 0. And so this whole thing is being multiplied by 0. So this last term goes away. All right? The other way you can learn it is that if there's ever a term without an x next to it, whenever you do the derivative, it just kind of disappears. So this last term is going to disappear. And from here, what you end up with is, well, you end up with derivative p of x is going to be this 10,000 times 2, so it's going to be negative 20,000. 2,000, not 20,000, sorry. I'm definitely a little bit not too concentrated today. So negative 2,000 x plus this 3,000 that you see here, plus 30,000, sorry, plus 30,000. And because you had x to the power of 1 minus 1, you end up with x to the power of 0. And anything to the power of 0 is just going to be 1. So it's 30,000 times 1. That is your derivative in this case. So remember, guys, anything to the power of 0 equals 1. This is just a mathematical rule. I've explained it a couple times, but just very quickly, if you have, I don't know, 2 to the power of 3, it's going to be 8. 2 to the power of 2, it's going to be 4. 2 to the power of 1, it's going to be 2. 2 to the power of 0, as I said, is always going to be 1. Now, if you go in this direction, you're doing times 2. You're doing times 2. But if you work backwards, you're going to end up doing divided by 2. Divided by 2. And 2 divided by 2, one last time, gives you 1. So anything to the power of 0 equals 1, because eventually you will inevitably reach itself being divided by itself, which will always equal 1. That is why anything to the power of 0 equals 1. I think there's like a couple other ways to like prove it, but that is my favorite. So all that blah blah was all of us to agree that for part F, part I, this is the answer. And then for part AA, you need to show that the salesperson's selling price does not maximize their average monthly profit. Interesting. Does not maximize. Does not maximize. So whenever you have a problem that talks about maximizing, optimizing, finding a maximum, finding a minimum, you can immediately consider doing derivative equals 0. Okay? And why would we want to do derivative equals 0? Because, ladies and gentlemen, imagine you have like, I don't know, like a parabola like this, okay? So this is x, this is y. When you have the original function, for example, just a normal like f of x, you plug in x, you get a y, you get a bunch of points, right? You plug in x, you get a y. But the moment you have the function in its derivative form, you plug in x, and you get a slope. And so basically, when you have a derivative, the x that you plug in, you're asking your function at an x of, I don't know, 2, what is the slope? Instead, over here, if you plug in an x of 2, you're saying, when x is 2, what is y? And that gives you a set of points. This other one, technically, it's also a set of points, but the y is now slope. See? So I said then you want to do a derivative equals 0, which is the same as saying that the slope equals 0. So why would you want a slope equals 0 to find the maximum, minimum, and all that stuff? Well, think about it. So let's focus on this parabola here. At this point over there, which we will call x equals -1. So at x equals -1, what do you think is the slope? Well, immediately you should be thinking the slope is a positive or negative. The slope is positive because it's going up. So here you have a positive slope, right? Let's say that it's going to be positive 3. I'm just going to make it up. I don't care. Deal with it. So this is a slope of positive 3. If you keep going, for example, right next to it, this is still a positive slope, but it's a little bit less. We're going to call it positive slope of 2. And if you keep going, eventually this is, I don't know, positive 1, right? And right at the maximum, right at the point of optimization, right at the vertex, wablam, wablam, you have a slope of 0. So wherever, and this is a massive idea, you guys, whenever you have a slope of 0, you have a max or min. It is a rule that always applies. Even if you have a parabola that goes like this, if you keep calculating all these slopes, so this is, I don't know, -3, then this is -2, this is -1, eventually, this is a slope of 0. So if you do the derivative and you equal it to 0, which we said this is for finding the slope of 0. And so from there, you find the x value. This is a fascinating thing. From here, you find the x value of the vertex. So here you find the x value where the slope is 0. That is the main idea. When you do derivative equals 0, you are finding, whoops, that would have looked really weird. You are finding the x where slope equals 0. So finding the x where my function is optimized, which can be at a minimum, it can be at a maximum, but those are the points of optimization. And so if you take this derivative here and you equal it to 0, you literally already gain a point. That is already a way for you to get a method point by saying that this equals 0. Okay, and if this equals 0, basically what you're saying is that 0 equals -2000 x plus 30,000. And how do you get x from here? Well, you can say plus 2000x plus 2000x. So 2000x equals 30,000. You divide by 2000. You divide by 2000 to get x alone. X has to equal, quick maths, 15. So at x equals 15 is your maximum. And so here we are showing that the salesperson's selling price does not maximize their average monthly profit, because to maximize their average monthly profit, it is exactly at x equals 15, and over here they are selling at 16. And you might be thinking, wouldn't a better price be like more expensive because then you earn more? And that's when all your econ guys say nuh-uh, because of elasticities. And I'm not going to get into that because this is a math video, not an econ video, but intuitively I'm going to tell you that if something is way too expensive, a lot of people will stop buying it. But if it's a little bit more expensive or a little bit cheaper, you might end up with a lot more people buying you. A simple example, let's say you're selling sandwiches, right? And you can choose between selling the sandwich at 10 euros or 20 euros. At 20 euros, you are selling less sandwiches, but they are more expensive. At 10 euros, you're selling a lot more sandwiches, but it's also a lot cheaper. And so which one gets you more money? It depends on how your consumers behave, okay? And so in this case, the maximum is actually right at 15 instead of 16, okay? And if you want to get very, very nerdy with this, you can go to Desmos, graph it in your graphing calculator. But just so you guys see, and just so you guys finish getting convinced, if I graph my original function, so my original function is p of x equals -1000 x squared plus 30,000x, that's 30,000, right? Yes. Minus 210,000. We found that our optimum is at x equals 15. And so if I zoom out, and here is my, well, I gotta go all the way up because we're talking about big values here, but okay, this graph is definitely not friendly. Let me do it in my graphing calculator, see? Usually Desmos is good for like doing it quickly, but in this case, seems like not so much. So just so you guys finish getting convinced, 210,000. I'm going to change my window a little bit, so I'm going to say x is 0. My max is going to be 30 because at x equals 15 is my max, right? And my y max is probably going to end up being really big values. I'm just going to put like whatever. Let's work from here for now. So we're going to graph this. All right, clearly my y value is like insanely big. So I'm going to cut down on 2 zeros maybe. Okay, now it's not enough. I'm going to add 1 0 now. It's still too big, but we're closer. All right, whatever. Let's just go back to the original point. I'm just trying to explain that your maximum has to be if you do calc max. Okay, this is just to show the idea. This is not part of the exercise. So you do left bound here, right bound here to find your maximum. Your maximum is right at 15. I mean 14.999, whatever. You take that as 15. So right at x equals 15, you have your maximum. And how did you figure out that that value was your maximum? Because we did derivative equals 0. We found that x equals 15. And so at x equals 15, you have your maximum. At 16, you're not at your maximum. You're actually earning a little bit less. Okay? In fact, if you use trace a little bit to the right for 16, you're earning less. Here you're earning around 13,000. While out of 15, you're earning 15,000. So it's a small difference between 15,000 and 13,000, but companies care about money, and to be honest, so should us. Maybe not as greedy, but that's another topic for another day. Anyways, you guys, that is for part F, part double I. Alright, you guys, and now for this last part, we have that Mosaic Industries negotiates a new deal with their phone case supplier. Under the new deal, the supplier agrees to discount the cost of each case based on the number of cases purchased by Mosaic Industries. And so, careful, here it says that the cost charged by a supplier for each case can be found using the function blah. Okay, so this is the new cost charged for each case, where n represents the number of cases sold by Mosaic Industries. And through this, we need to find the function that can be used to find Mosaic Industries' average monthly profit using the new deal from the supplier. And so this is actually fairly easy, but you really need to be organized in your approach. And so I'm going to scroll up, and well, I had to rewrite it because I'm recording again. But basically, originally, if you go back in the video, we talked about how we found the income using this part here. So this would be the income. And we talked about how this here was the fixed cost. All right. And we also talked about this here is the cost per phone. And so at some point, there are two things that happen. At some point, we said that n was this, which makes complete sense because we're talking about this n here. And at some other point in time, we said that this n, the cost per phone is 10 times n. And it's 10 times n because this 10, which is the same as this 10 here, is the same as this 10 right here. And so Mosaic Industries per phone had to pay 10 euros. And so what's happening now in part G is that now they don't charge them 10 euros per each case, they charge them this. And you might be telling me, okay, but that's not an actual number. That's not like that they're charging 8 or they're charging 9. And I say, I fully agree with you. Now what they charge depends on the amount of phones that they buy, which makes sense, right? I mean, a classic is that, I don't know, if you buy 10,000 bottles of wine, it's cheaper than if you buy 100 per bottle because they give you like discounts for making such a large order and stuff like that. And so that is what's happening in part G. Okay, so basically, this thing that I highlighted in pink, I mean, put in circle in pink, is like it's your 10. Okay, so this used to be 10, right? And now, technically, your equation is going to end up as x times 20,000 minus 1,000x. So your income is still the same. Your fixed cost is still the same. But over here, technically, you have the cost per phone and the amount of phones. And so if you go ahead and plug all of this in pink is from part G. So this guy here. And this in blue, the n, is still the n from here. All right. So you've plugged all of that in. Technically, your equation is now, well, this is not going to change, right? I make sure I have the right amount of zeros. All right. Minus 1,000x minus 10,000 minus, and here's the juicy part. So you plug in C of n. So C of n is 10 minus 0.0001. So 10 minus 0.0001 n times n, right? And we said that n was this guy. Times 20,000 minus 1,000x. Now, we're almost done, right? And the one thing that we're missing here is that how many variables do I have? The amount of variables I have, for example, in this line here, okay, which was our answer like back in the day, it only has x's. So yeah, you have an x here, an x there, and an x here. And right now, how many variables do you have? You have x, but you also have n. So yeah, you have an x, and here you have an n. And so you need to take care of this n. So what is n, you guys? N, as we've seen all along, is this. This is n. And so yes, you're going to end up with a crazy, nasty sort of equation, but trust the process and it's going to be fine. And so now I'm going to start like working with these numbers to make it look a little bit prettier. So on the one hand, I can distribute here. Okay, so on the one hand, I can end up with 20,000x minus 1,000x squared. This minus 10,000 stays the same. I'm going to put check marks just like make sure that I've done everything, right? So minus 10,000. And here I can have minus 10 minus 0.0001 times n. And we know that n is 20,000, right? Minus 1,000x. All right, so just to be very clear, because I know that this part can be very confusing, this n got plugged into this. Now, where does that come from? From this, okay? All right, so I already did this parentheses, this part, this n, and now for this last part, I have 20,000 minus 1,000x. And so from here, I just need to plug in, combine stuff, basically see what happens. All right. All right, cool. So technically, yeah, this is fine. All right. And so from here, this thing on the left stays the same. Nothing to combine yet. And now in the parentheses, it gets very exciting. For the parentheses, I suggest that you first do what's inside first. So for example, first distribute from here, okay? So first I'm going to do that. So that means I'm still going to keep the minus on the outside, 10. And here I have the 0.001 times the 20,000. How much does that give me? Here I have 0.0001 times the 20,000. gives me 2. It literally gives me 2. So here I have minus 2, and then it's negative times negative, so it's plus 1,000 times the 0.0001, 0.1. So here I end up with 10 minus 2 plus 0.1x. Close parentheses. My other parentheses is still the same. So yes, these are a lot of lines of math, but as you can see, I'm just trying to take my time, trying to go slowly, do one thing at a time. So here on the left side, again, nothing's going to change. I'm not touching anything over here just yet. But this parentheses here, this first one, I can combine the 2 and the negative 2, so that gives me 8. And here I have my 8 plus 0.1x times the other parentheses. Alright, and now I think I'm like 2 lines from finishing this, right? And so now what jumps out at me is that you have 2 parentheses next to each other. So from here, you can do the classic like, so whenever you have 2 parentheses next to each other, what you're sort of supposed to do is that you multiply this with this, so you end up with AC plus AD, and then you do this with this, plus BC plus BD. Alright, so like everything multiplies everything. It's usually called FOIL. At least that's how I learned it. It has to do with like the first with the outer, then first with inner, then outer with last, stuff like that. See, so this is for first, outer, inner. It's just a way to remember like what most multiplies what, okay? I don't recall 100% how it was. I just know that it's called FOIL, so you can probably Google it. Visually, this is what we're doing, okay? So, from here, everything on the left stays the same. So I'm going to rewrite it one more time. So 20,000 x minus 1,000 x squared minus 10,000. And then here you're going to have this 8 times this. So it's going to be 8 times this 20,000. So it's going to be, well, there's a minus right outside, right? So I'm going to keep that alive for now. So this negative is going to stay. So I end up with positive 160,000. And then this times this gives you negative 8,000x. And then this times this, it's going to be 20,000 times 0.1. So that gives you plus 2,000x. And then this times this should give you negative something. So it's going to be 10,000 times a negative 0.1. So that would be negative 100x squared. Why is it x squared? It's x squared because you are doing an x times another x. See? Alright, and so from here, the thing on the left still remains untouched. And I know it's annoying to rewrite it, but due the day of the test, you can just not write it until the very end. See? I just care about the parentheses. But anyways, so I go back over here, the negative still stays. I'm still working with the parentheses. And so here, I can add these two together, right? So you end up with 160,000 minus 6,000x minus 100x squared. Right? And now I'm finally approaching the last lines of math. Okay? And so from here, you can distribute this negative, right? So this negative is going to change the symbols of everything. So you end up with 20,000. Oop, that looks like a big number. So 20,000x minus 1,000x squared minus 10,000. And then this symbol is going to change everything. So it's plus 160,000 plus 6,000x and plus 100x squared. And so if you combine everything from here, if you do, for example, this with this, right, you're going to end up with negative 900x squared. If you now focus on just the x's, you would be thinking like this one with this one, right? And that is going to end up being plus 26,000x. And last but not least, you can combine all of these different sort of numbers. So you have 160,000 minus 10,000, right? And so notice one small thing I missed here, and I just noticed, okay? When I distributed this negative, I should have kept this negative here. See, I mean, it would have ended up as negative, is what I'm trying to say. So small detail that I just noticed, instead of plus over here, I should have put this as minus. Okay, so we have minus 10,000, minus 160,000. Over here, end up with minus 170,000. 1, 2, 3. And so now, for part G, the function that can be used to find Mosaic Industries' average monthly profit, you can think about it as like your new P of X. So the new P of X is what I just found, which is negative 900 x squared plus 26,000 x minus 170,000. If you're wondering how you get these 3 points, you get 1 point for reaching this as an answer. You get a method point for doing this thing here. So this is another method point. And your last method point is just like doing this whole distribution thing over here is another method point. Okay? So there's a method point for realizing that you gotta do this step here, like this difference, right? Another method point is actually distributing and doing the math. And then getting it all correct, getting the answer is on last point. See? So I also mentioned this because, interesting. It's a lot of lines of math. You might not get it all right, but just by plugging in, just by following the process, just by doing the right method, you can get 2 out of 3. Not bad. All right, trust the method, trust the process. And now for part H. You know, they say hence. So anytime they say hence, it's like therefore, and it's a big hint. From part G, you need to use for part H, you need something from part G. So hence, find the selling price per case that Mosaic Industries should choose in order to maximize their average monthly profit under the new deal. And so from here, I can immediately identify that like the format of my function is the format of this. And this, ladies and gentlemen, is a quadratic formula. It's a parabola, okay? And so with a parabola, if you want to find the max or minimum, in this case, we want to maximize profit, right? So the maximum, which would be the case on the left here, right? Basically, the maximum or minimum is always going to be at what we call the vertex, okay? And so the vertex, this is something that actually gets asked from me a lot. It's basically like, how do you find the maximum point, right? And so you have 2 choices here, all right? One of them, and I'm just going to write it out. So one of them is that you get the derivative and you equal to 0, all right? When you find the derivative equal to 0, derivative helps for finding slopes. And so basically, for example, here you have a slope of, I don't know, 1. Here you have a slope of 1/2. And right at the vertex, surprise, right at the vertex, you have a slope of 0. And so wherever your slope is 0 is where your derivative is 0. And so doing the derivative equals to 0 helps you find the x value where your slope is 0. Where slope is 0. And that can help you find the amount of cases sold, and through that you find the selling price. Okay, so that's one choice, just doing the derivative. The other choice is that because it's at the vertex and because you know it's a quadratic, you can just find what we call the axis of symmetry. And so whatever is the x value, so x value, axis of symmetry, will give you the vertex. And so that's 2 ways to do it. You either do axis of symmetry, gives you the x value where you have the vertex, or do you do the derivative, and that also gives you the x value of the vertex. Okay, so it's 2 ways to do the same thing. I'm first going to show axis of symmetry, okay, just because I think it's a little bit more friendly, but I will show both. All right, so stick around if you want to see both ways, or just stay for this first one. So in your formal booklet, you can look up the axis of symmetry. And so the axis of symmetry again, it's like what cuts your parabola like in half, right? The cool thing about parabolas is that they are perfectly symmetrical. That is why you have an axis of symmetry. So for example, on this point here, the distance from here to here is the same as the distance from here to here. Exactly the same. I don't know, from here to here, it's the same distance as from here to here. And so, axis of symmetry also helps you find zeros. If you know that 1, 0 is at, I don't know, negative 1, comma 0, and that your axis of symmetry is at x equals 3, then you say, yeah, so from here to here, it's 4 units. So that means from here to here, it's 4 units. Your other 0 has to be at 3 plus 4, comma 0. 7, comma 0. So, look at that. Axis of symmetry is very useful for many different things. In this case, we will use it for finding the maximum point, okay? And so axis of symmetry gives you this line in green, okay? It would give you the x equals 3 in the example that I gave. Now, what is the formula? It's this. It's negative b over 2a. What is b? What is a? Well, your function, your parabola, we call it ax squared plus bx plus c. And through there, so b is the one that has just an x next to it, and your a is the one that has the x squared next to it. And so if I go back here and I try to use the axis of symmetry, method, you have negative b over 2a gives you the axis of symmetry. And so in this context, a is negative 900 because of this here, and b is 26,000. All right? And just to finish the idea, c would be this. So c would be negative 170,000. We don't need c here, but I just want you to see and observe like, okay, so that is how you find a, b, and c, okay? So if you plug into the axis of symmetry, you have negative b, which would be negative 26,000. Negative, yeah, okay. And then divided by 2a, so 2 times 900. So in other words, you have negative 26,000 divided by 1,800. All right? Now, I just noticed, dude, I am very not concentrated today. I just noticed that a is negative 900. And so here I did plug in 900, but I forgot to put a negative. So once again, I'm leaving that sort of mistakes on my video because it happens to anyone. So I should have plugged in negative 900. What is one way I realized? I realized that my axis of symmetry should be positive or else it wouldn't make sense. You can only sell a positive amount of phones. You can't sell a negative amount of phones. So that means that this over here ends up being negative. A negative and a negative makes the whole thing positive. So 26,000 divided by 1,800. Now this, in your calculator, will give me, this on my calculator is 26,000 divided by 1,800 gives me 144. So 144.444. All right. 2 times this. 26,000. All right, looks clean to me. All right, and I just realized here, oh my god, I'm gonna roll today. I put an additional 0. Sorry, guys. All right, so you end up with 14.444. So my bad. Wrote too fast on my calculator. It's been a rough week for me, guys. Sorry. So 14.444, that is what we end up with for the x value of the axis of symmetry. And so what is x in this case? Well, we know that we know that y is profit, and you know that x is selling price. And so actually from here, you don't need to find like the y value of your vertex. Just by having found that this is 14.4, you're good to go. So your final answer is 14.4 euros. If they were asking for, okay, and at this price, what is the profit? You would have to plug in, and this is just to have like a complete image of the exercise. if they were asking, okay, what is the profit, like what is the maximum profit that they get, you need to plug in this 14.4 back into your equation, okay? And why do you have to do that? Because that gives you the y value, and so that would give you the vertex, okay? That would give you the maximum. And so just to show it, this is not part of the exercise anymore, but just to show it, in case it happens to you in the future, that it's like, okay, find the maximum profit, you first find the x value of the vertex, and then you plug it in, okay? And then you plug it in order to find the profit. So the profit is 177.76, okay? So if they sell at 14.4 per phone case, their profit is this amount, and that is their maximum profit because it's the maximum point of my parabola. Ladies and gentlemen, sorry about the small mistakes at the end, but I like to leave that on the video just to show that we're all human, we all make mistakes, and check your work. Once I realized I was getting a negative value for my axis of symmetry, I said, nah, something is wrong there, and lo and behold, I forgot to plug in the negative on the 900. See? So we all make mistakes, we're all human, and if you have an intuition that something might be a little bit wrong, just double check. Take your time, just like I did, all right? Anyways, that is for number 5, and that is for the entire paper. I hope it helped.